Hello everybody, and welcome to our review for the college algebra homeworks. We are just going to go through the various homework assignments, and we are going to go through how to go about solving them. So if you have not done so already, I highly recommend that everybody please try to do this on your own first. It really doesn't help much if you just watch me do it for you. So I'm going to hope that everybody has already done this, and this is kind of to review it. We're also providing some answer keys and all that, but this will hopefully be a little bit more useful. Now, the first one is extremely basic, really not even about algebra, really about basic arithmetic review, a little bit of PEMDAS. And in the first couple of questions, I asked you to do this without a calculator. Essentially, the way to do something like this, like 17 minus 22, whenever you have a subtraction of a number that is greater than the number that is the base for the subtraction, you still need to subtract the smaller one from the larger one, but the sign is going to be a negative. So, for example, in 17 minus 22, you actually do 22 minus 17, and that, of course, is 5. But because the bigger sign is the negative one, your answer is going to be negative 5. And obviously, if you do this on a calculator, it works very simply. But let's try something like this. Let's try 54 minus 87. Now, 87 minus 54 is 33, because 7 minus 4 is 3, and 8 minus 5 is 3, so it's 33 overall. But again, since the bigger number is on the negative side, so your answer is going to be negative 33. You know, if, for example, you had negative 54 minus 87, well then, since both were negatives, you add them together, and your answer is going to be negative as well. So the answer to this one, of course, would be, well, 11 plus 130 is 141, and so it would be negative 141. If you do something a little bit different, you do a multi-part. Since there's no multiplication over here and there's no real PEMDAS to worry about, there's no real order of operations, you just do them one at a time. If there were multiplication or exponents or parentheses, you'd have to worry about this order of operations, but you don't have to worry about that in this case because they're all plus or minus operations, and addition and subtraction operations are really the exact same thing in just different forms. You can just do them one at a time. So negative 23 plus 14. Again, the bigger sign is negative, the smaller is positive. So subtract and use the sign from the bigger one. So you do 23 minus 14, which is 9. And since the 23 is negative, this becomes negative 9. Minus 16, well, this is negative 9 minus 16, so they're both being added to the negative side, so you add them. 16 plus 9 is 25, so you get to be negative 25, so we can make this as negative 25. Negative 25 plus 5. Now here, again, you're going to have, there are different signs, negative 25 plus 5, so you're going to have to subtract, so it's 20, but the sign was on the negative, so this would be negative 20 altogether. And then you've got negative 8, minus 7, minus 20, minus 8, minus 7. Basically just add them all up and the answer is negative. And so your final answer is going to be negative 35. Okay, now let's get to the middle ones as we move a little bit further along in the complexity of the first homework over here. And here we are going to use PEMDAS. Now, if you'll recall, PEMDAS was the order of operations. The first thing is the thing inside the parentheses. The second thing is whatever exponents there might be. Then you've got MD, which stands for multiplication and division, and since multiplication and division are the exact same thing, just in opposite forms, there is no, you can do division first, you can do multiplication first, it makes no difference. And then finally, you've got AS for addition and subtraction, and again, you can do those in any order you like. Okay, now in this case, we've got no operations are within the parentheses. There's a 17 in these parentheses, but actually there is one operation over here within the parentheses, so that's the one we're going to do first. And the one we're going to do first over here within the parentheses is the square root, that's the symbol for square root of 64. And for that we are going to use 8, because 8 times 8 is 64. So we're going to make that into an 8. Let me make this a little thicker so it's a little bit easier to see. Okay, so we've got an 8. Now we've got one more, we have no more operations within the parentheses, but we do have an exponent, and that is 2 to the third power. 2 to the third power is 2 times 2 times 2, which is 8. So we can put an 8 here, leave the 17 in parentheses, minus 3 times 8. Now, we've got no more operations within the parentheses, so now we can look at, okay, we've got two multiplications, 8 times 17 and 3 times 8, and we've got one subtraction, which is this function over here. So let's do the multiplications first, and it makes no difference which multiplication we do first, but let's go left to right. 8 times 17, which is 136, and again, the way I did that in my head is 8 times 7 is 56, and 8 times 10 is 80, so 80 plus 56 is 136. And then we can do this multiplication. Leave the minus sign there because we haven't operated it yet. 3 times 8 is 24. Now we've only got one operation left, and that's subtraction, which is 136 minus 24, which of course is 112. And there is your answer. The next one we can do in the same way. Here we do have a couple of operations within the parentheses, so that's the ones we want to do first. 17 minus 3, we'll change that into a 14. 14 minus 6, we'll change that into an 8. Now, we've only got two operations left, 14 times 8 and then the minus 22. The multiplication and division one comes first, so we're going to do the multiplication first, and that's 8 times 14, which is 112, minus 22, only one operation left, 112 minus 22, which is 90. For number 6, it's a little bit more complicated, but still nothing too bad. We've got operations within the parentheses, but even within the parentheses, we've got different types of operations. For example, within this parentheses on the left side over here, we've got an exponent. So let's do that first, because PEMDAS applies within the parentheses as well. So let's do 3 squared first, which is 9. So that leaves us 10 plus 59 minus 9 divided by 24 minus 4. Now, the only things we have left are operations within the parentheses. 10 plus 59 is 69, minus 9, of course, is 60, divided by 24 minus 4, which is 20. And remember, we did the subtraction and the addition before the division because they were inside of the parentheses. And you want to do operations within the parentheses first. So we did these operations first within this parentheses, then this operation second. Now we've only got one operation left, which is 60 divided by 20, which is 3. Okay, let's continue with homework number 1. Going over homework number 1, we'll finish it in this clip over here. Number 7, we have again an order of operations principle where we've got a multiplication function, a division function, and an addition function. Multiplication and division are on the same level, so we can do either one first. I'm going to do the division first. It's easier to deal with smaller numbers than with bigger numbers, and division gets you smaller numbers. So 15 divided by 5, which we're going to, of course, make 3. And then we've got 16 times 3 plus 12. We'll do the multiplication before the addition. So we have 16 times 3, which is 48. And then finally we do the plus 12, and we get 60. Simple enough. On number 8, we've got all 4 types of functions. We've got an exponent function, we've got parentheses functions, we've got division, we've got a subtraction, we've got a whole bunch of them. We've got a multiplication over here. So first we have to do what's inside parentheses, and 9 plus 33 minus 6 is, of course, 36. So we can make this 36. Now we have we have an exponent function, so I'm gonna make this into a 9 because 3 squared is 9. Then we've got, of course, the 24 times 36 divided by 6, so we could multiply 24 by 36 and then divide by 6, or, since as I did in the last question, I think it's a lot easier to do 36 divided by 6, which is of course 6. First, so we've got 24 times 6, and then we've got a subtraction and a multiplication, so we'll do the multiplication first. 24 times 6, which is 144, minus 9 is 135. Okay, next example. Here again, we've got parentheses functions, exponents functions, all sorts of things. So let's do the parentheses first over here and on the right side. Now on the right side, we've got a division and a subtraction, so we'll do the division first. 10 divided by 5 is 2. So over here, we've got 9 minus 2, so we've got a 7 over here. On the right side, we've got 6 plus 3, which of course is 9. And now we've got an exponential function. Well, we have really 9 squared plus 7. So of course we do exponents first. That's much earlier in the order of operations. And we get 81. Then we've only got one function left, and that's the addition to get our final answer, which is 88. Our next example deals with an imaginary number because it has the 3 times the square root of negative 16. The square root of negative 16 is, of course, you can separate that out into, well, actually, let's do the parentheses first, because that's, of course, first in our order of operations. So 6 minus 3, which, of course, is 3. So over here, we've got 3 to the negative 3. Over here, we've got the square root of negative 16, which, let's keep the 3 on the side for the time being. We can change this into times the square root of positive 16 times the square root of negative 1. And the square root of negative 1 we're going to turn into an I. I for imaginary number is the same thing as the square root of negative 1. So we can say 3 times the square root of 16, which of course is 4, times I, plus 3 to the negative third. 3 times 4 is, of course, 12. That's an easy one. So we can turn this into 12i. On the right side, we've got 3 to the negative third. Now, a negative exponent means 1 over the number. So this is the same thing as 1 over 3 to the third. And 3 to the third is 3 times 3 times 3, which is, of course, 27. Now, there's no real way to combine these because the one on the left has an I and the one on the right doesn't. So this is pretty much the simplest answer we can get. That's the best answer we can get. 12i plus 1 divided by 27. Okay, let us look at number 11 over here. We've got 3 to the negative 1/4 times 17 minus 1, which of course is 16 to the 1/2. Okay, let's do the parentheses operation first. We'll make that into a 16, no problem there. Negative 1/4 means 1 over 3 to the 1/4. So we can change this to 1 divided by 3 to the 1/4. Now, a fractional exponent is the same thing as a root. So what this really is 1 divided by the 4th root of 3 times 16 to the 1/2. And of course, 16 to the 1/2 is the same thing as the square root of 16. Because again, a fractional exponent simply means a root. 1/2 is the same thing as the square root of 16. Now the square root of 16 is what times itself will give you 16, which of course is 4. So we can change that into a 4. And when you have a fraction times a number, you can simply put the number on top of the fraction because it's 1 times 4. So on top of the fraction is 1 times 4, which is 4. And on the bottom of the fraction is the 4th root of 3, and there's really no way to simplify this any more than it is now. So there you have your best answer. And finally, number 12. Number 12, again, we've got the parentheses, we've got exponents, we've got addition, we've got subtraction, we've got multiplication. So let us do them one at a time. Let's start with this, 123 minus 23, which is 100. 1 minus 3, which of course is negative 2. Now we've got an exponent, 100 to the 1/2 power. Now 100 to the 1/2 power means the square root of 100. What times itself will give you 100, which of course is 10. Then of course we've got still the plus 57. And then minus 12 times negative 2. Well, 12 times negative 2 is negative 24, so it's minus negative 24, which is the same thing as plus 24. So you've got 10 plus 57 plus 24, which gets you 91, as those are our only functions left. And that is your answer to question number 12. Homework 2 is about manipulating algebraic expressions. What we're going to do here is we're going to do multiplication, addition, division, subtraction, and even some functions involving exponents two algebraic expressions. An algebraic expression is defined as an expression with a variable, with an x, with a y, with both, with other letters, anything besides for just plain old regular constants, which are considered numbers. So let's take a look at number one. Now, number one, you've got a multiplication function and you have a subtraction function. Now, remember, you can only do a subtraction function or an addition function if the two terms have the exact same variable. So there may not actually be able to be any combining over here. However, let's start over here. So we can start with this multiplied by this, a monomial by a monomial. And when that happens, you see what you can multiply together. The 8 and the 3 can be multiplied together. That, of course, gives you 24. The x can't be multiplied by anything because there's an x here and no x here, so the x just stays the way it is. The y, on the other hand, can be multiplied. When you multiply two numbers of the, or two letters of the same variable, in other words, two y's, you add the exponents. Since this y is really the same thing as y to the first power, and this is y to the fourth power, y to the first power times y to the fourth power, which is like y times y, gets you y to the fifth power. You add the exponents, so what you have over here is 24 times x times y to the fifth power. Over here, you've got 3 times 7x, so 3 times 7 is 21, and the x stays by itself. And there's nothing you can do beyond this because the two terms do not have the same variable, so this is your answer. The second one here, you've got a situation where you've got multiple terms in each set of parentheses. It's the 2x minus 5 being multiplied by the entire x squared minus 3x plus 1, which means each of these terms, the 2x and the negative 5, has to be multiplied by each of these terms. And then in the end, we'll see what we can do in terms of combining the variables. So first, let's try 2x times x squared. Well, the 2 stays by itself because there's nothing to multiply it by. X times x squared is x to the third because this is really the same thing as x to the first. And you add the exponents, so this becomes x to the third. 2x times negative 3x becomes 2 times negative 3, which is negative 6. X times x, which is x to the second, because we added the exponents, the 1 and the 1. And then finally, 2x times positive 1 is simply positive 2x, because anything times 1 is itself. Now let's try the negative 5, which is the second term. Negative 5 times x squared is negative 5x squared. And I'm going to put it over here. And the reason why I'm going to put it over here is because these two have the same variable. If they have the same variable, you're going to be able to combine them. That's why I'm going to put things that have the exact same variable on the same line. Then we've got negative 5 times negative 3x, which is negative times a negative, so it's a positive. 5 times 3 is 15x. And then finally, the last one, negative 5 times positive 1 is negative 5. So here, we can kind of add these terms together. We can combine these terms to the extent that they have the same variable. The 2x cubed is going to stay because it doesn't have the same variable at all. These two terms can be combined. Negative 6 minus 5, just add, or in this case, subtract the coefficients. Negative 6 minus 5 is negative 11. And when you do that, of course, the variable stays the same. Just like if you had 6x plus 5x would be 11x, so negative 6x squared minus 5x squared would be negative 11x squared. Here also you have the same variable. 2 plus 15 is 17x. And the negative 5 stays by itself, and that is... There's nothing more you can do to combine these because all of these have different variables, all of the terms in there. When you have a situation like this, where there's no multiplication going on, in other words, you don't have this whole term being multiplied by that whole term, instead you have this whole term being subtracted. So here we're going to try to line things up with the same variable. Let's say, for example, this is a negative negative, so this term gets added to this term, because again, a minus and minus, a double negative is a negative. And this is going to be on the same line as this because they're the same variables. So we can say positive 2x squared y to the third. The middle is a negative negative again, so it's a positive. And again, the variable is xy, so we'll put it under this term, which also has the variable xy. So we'll say plus 3xy. And the last one, which is negative positive, which is a negative, we'll put it over here because it has the same variable as the y squared. So if we combine these, this is the same variable as this, so we can add the 3 and the 2, and we've got 5x squared y to the third. The middle, we've got negative 1xy. Remember, when there's no coefficient, it's assumed to be 1. So negative 1 plus 3 is positive 2, and the variable stays the same, which is xy. And then you've got 4 minus 5, which is negative 1, or just plain negative y squared. And because of the fact that you have no more terms that have the same variable as each other, this is the final answer that you have to leave it with. Number 4, for homework number 2, is a division problem, which is worked in really the same way. Just like when you multiply two letters, two variables, you add the exponents. When you divide them, you subtract the exponents. So over here, we've got constants, we've got numbers that are being divided by each other. Well, first of all, the entire thing is going to be a positive divided by a negative. So the entire answer is going to be a negative. You know that right away. 24 divided by 2 is 12, so we can put a 12 here. X to the second minus divided by, x to the fifth is x to the second minus 5, which is x to the negative 3. So we can leave that as x to the negative 3. Then y to the 13th divided by y to the second, well, you have to subtract negative 2. So it's 13 minus negative 2, which is y to the 15th. Now, if you wanted, remember, something to a negative exponent is the same thing as 1 over that amount. So you can also write it, which is probably the best way to write it, would be 12y to the 15th, and then put x to the third on the bottom. Essentially, we just kind of flipped it. Instead of making it x to the negative third on top, we made it x to the third on the bottom, which is the same thing. This example over here, well, here we have a situation where one term is being added to another term, but there's only one variable that's the same as each other. Essentially, we've got, if you put this term on top, the one on the left on top, remember, this is not being multiplied, so you don't have to distribute. You don't have to multiply them out. This is just being added. So you add the 10x squared, but there is no 10x. There is no 10x squared on the other term, so we're just going to put it over here by itself. The 7x you can put over here because you can combine it with this term. You always look to see if they have the same variable, and of course there's nothing similar to the 1. So we can put the 10x squared over here. It's 0 plus 10x squared. 5x plus 7x is 12x. And then we've got minus 1, and there's nothing really you can do over here to simplify it any further because there are no two more terms with the same variable. The next few problems are similar to the ones that we just discussed. They're all really doing the same thing. In number 6, you're also going to want to write out the first term. So let's say 6x plus 2y plus 9. Now, this is being added to the second term. So we want to try to combine all the terms that we can combine. Now, because this is a plus sign, that means all these signs stay the same. This is a negative, this is a negative, this is a negative. So the 3x lines up with the 6x, and we'll call it negative 3x. The 5y lines up with the 2y, and of course negative 2y, and then the negative 8. So now we can combine them. 6x minus 3x, 3x. 2y minus 5y, well, 2 minus 5 is negative 3, so we'll call it negative 3y. And of course, 9 minus 8 is positive 1. And since they're all different terms, this is the best answer that you can come up with. Number 7, we are going to multiply out, because here you do have monomial multiplied by a binomial, and then another monomial multiplied by another binomial. So we're going to use the distributive property. This times this, and then this times this, and then we'll do the same thing on the other side. X times x, x to the second power. Remember, it's not 2x. X plus x is 2x, because when you add them, you add the coefficients. But when you multiply them, you add the exponents. So this is x to the first, this is x to the first, so that's x to the second, plus x times 1, which is 1x, or x. Now on this side, we can do the multiplication out also. Negative x times x, which is negative x squared, that's this times this. And then this, which is negative x times negative 1, which is positive x. Now, can we combine them? Well, yeah, we can combine this with this, x squared minus x squared, which is 0. Which is, 1x squared minus 1x squared is 0x squared, and 0 times anything is 0. And then you've got x plus x, which is 2x. So the final answer is just plain 2x. Number 8 is a combination also, where it's a monomial. That's the 2x squared times a polynomial, really a trinomial over here. So you would distribute this in all three directions. 2x squared times 3x squared, well, you can multiply the base, 2 times 3, which is 6. X squared times x squared is x to the 4th power, again, because when you're talking about the x's, you add the exponents. The second term, 2 times 5, 10, and x squared times x, x to the 3rd power, right? This has an exponent of 2, this has an exponent of 1, so altogether it becomes x to the 3rd. Then you've got 2x squared minus 4x, which is negative 4 times 2, which is 8, and the x squared just stays because there's nothing to multiply it by. And this is now the best answer. Nothing more you can do to simplify this, and that's your final answer. Number 9 is something that's a little bit more complex, but we have to realize this is y plus 7, and the whole thing is to the 3rd power. So that's really the same thing as saying y plus 7 times y plus 7 times y plus 7, and then of course you still have the plus 4 left over at the end. Well, when you do that, you got to do them separately because it's this times this, and then the product times this. So let's do y plus 7 times y plus 7 first. Now, if you recall, you do FOIL here, first, outer, inner, last. First is y times y, which is y squared. Then outer is y times positive 7, which is positive 7 times y, or positive 7y. Then inner is 7 times y, which is another plus 7y. And then last is plus 7 times plus 7, which is plus 49. And now you've got this whole answer times y plus 7. See, now now of course we could leave the plus 4, which we're not going to have to worry about right now. But this is what makes it a little complicated, because now you've got 4 terms times 2 terms. So each of the 4 terms has to be multiplied by each of the 2 terms. So let's do the y times everything. And maybe we'll make them on separate lines to try to combine them later on. So y times y to the 2nd, that's simple enough. That's y to the 3rd, right? Because you add the exponents. Now you've got y times positive 7y. So you got positive 7y to the 2nd, again, because the 7 doesn't combine with anything, but the y times y is y to the 2nd. Then you've got y times positive 7 again. And then you've got, actually the truth is, well, we can do it this way. We could have combined it earlier, but it really doesn't matter. We could do it this way as well. Either way will work. Plus 7y squared. And then we've got y times 49, which is positive 49y. Okay. Now, of course, at this, well, okay, let's leave it the way it is, and we'll combine the 7y. At this point, we could combine the two 7y's to make this into positive 14y, but, it doesn't really matter one way or the other. We could do it later, we could do it now, either way. Okay, 7 times y squared. Again, now we're doing the 7 times everything. So 7 times y squared is positive 7y squared. Then you've got 7 times 7y, which is positive 49y. Then you've got 7 times 7y again, which is another positive 49y. And then you've got 7 times 49, which is 343, I believe. And then you've got, of course, the plus 4 eventually, which we saved later on. So let's combine everything that could be combined. And let me make a little more room here. So we still have the y cubed, which isn't going to combine with anything. We've got 3 of these 7y squareds, and they're being added to each other. So it's 7 plus 7 plus 7, which is 21y. Then we've got 49 plus 49 plus 49, y, all y, which is 147y. And then we've got 343 plus 4, we've got plus 347, and that's our answer, because we've combined everything that we needed to combine. So actually, if we would have combined this and made this into 14y, it would have been a little simpler, because instead of multiplying each of these by 4 things, we would have only had to multiply them by 3 things. But either way, that works. Let's do a problem that's a little simpler. 2m times 2m, which is 4m squared. 2 times 2 is 4, n times m is m to the second. Then we've got the FOIL, so the outer, negative 6 times positive 2m, so that's negative 12m. Then we've got the inner, positive 6 times 2m, which is positive 12m. And then the last, negative 6 times positive 6 is negative 36. Now, the middle two, as you might notice, are going to cancel out. Positive 12m minus 12m, or negative 12m positive plus 2m plus 12m is 0. So your answer is going to be 4m squared minus 36. This, by the way, is known as the difference of two squares. Whenever you have two of the same terms, and the only difference is that there's a plus sign in one of them and a minus sign in the other, by definition, the outer and inner terms are going to cancel out, leaving the only the outer times the outer, the last times the last and the first times the first are going to be the only two terms. For example, if you have x, let's say, plus 3 times x minus 3, your answer is going to be x squared minus 9, because the middle two terms are going to cancel. X times x is x squared, outer is negative 3x, inner is positive 3x, and then the last is negative 9. These two are going to cancel out, leaving only the x squared minus 9. Okay, homework number 3 is about factoring, which is kind of the opposite of what we discussed last time, which was multiplying. So here what we're going to try to do is we're going to try to take these binomials, or trinomials as the case may be, and convert them back into two binomials, kind of the exact opposite of the FOIL process. Now, when you have a situation like this, where you've got a squared term, and then you've got a term with one variable, like an x in the middle, and then you've got a number on the last term, what you do is to try to separate it into two binomials. There are going to be two numbers in each of these parentheses. At the beginning, you put the term that's going to multiply up to the first term, which in the case of x squared, of course, it would be x and x. Now you have to figure out two terms that are going to multiply up to this number and add up to this number. Now, one trick you can do in terms of the signs is you can look at this last sign for the sign on the interior. If this last sign is a negative, then the two signs have to be different. There has to be one positive, one negative. If this is a positive, well, there are two ways to multiply up to a positive. You can have two positives or two negatives. In this case, the middle sign is the thing that tells you which one it is. So the middle sign is a negative, which means both sides are going to be negative. Because this is positive, both signs have to be the same, and because this is negative, those two sames have to be negative. So now we got to figure out what two numbers are going to multiply up to 18 and add up to 9. Well, we can look at the roots of 18. Well, let's see, 18 and 1, that multiplies up to 18. 9 and 2 multiplies up to 18. And 6 and 3 multiply up to 18. And if you look at these three, the only possibility that adds up to negative 9 would be negative 6 and negative 3. You may have to do a little trial and error. Once you do a few of these, it'll become a lot easier. But that's your answer, because negative 6 and negative 3 add up to negative 9, and they multiply up to positive 18. If you want to check out your answer, you can FOIL it. First is x squared, outer is negative 3x, inner is negative 6, and last is positive 18. The middle two combine to be negative 9x. And as long as this equals this, you know you have the correct answer. The second one is where you have a situation where you have a cubed number. Now, where you have a cubed number, in other words, y cubed, you're going to have a binomial and a trinomial. In other words, one of them is going to be a a two-termed expression, and the other one's going to be a three-termed expression. What's going to be over here is simply the base variable. Since this is y cubed, it's going to be y over here. And what's going to be over here is the third root of whatever this number is. The third root of 125 happens to be 5. It has to be something with an even third root. You can't say, for example, y cubed minus 100. It's just not going to work. So now, in order to determine whether this is a negative or a positive, you have to look at this sign. And this sign is a negative, so that means this sign also has to be negative. And again, this is very mechanical, so you just kind of have to memorize. You've got to practice a few of these. But on this side, the first thing is going to be that term to the second power, squared. So in this case, it would be y squared. And because this is a negative, the other two terms have to be positive. Essentially, if this were a positive, then this would have to be a negative. But because this is a negative, this has to be a positive. So this is going to be a positive, and this is going to be a positive. And in order to figure out what the how this works is that you put the number over here that's going to need to multiply with this number to get the last number, because remember, you're going to have the last term equal up to 125 altogether. So if this is 5, what times 5 gets you 125? And the answer is 25. So this has to be 25 over here. And for the middle term, you just put whatever this term is, in other words, 5, with the variable. So in this case, it would be 5y. So this is negative. The others have to be positive. And this number has to multiply up to the last number in the original problem with the number over here. So you've got 5 times 25. Now, if you multiply this out, obviously this should, you'd want to check it. If you want to check to make sure it's right, y times y to the second is y to the third, and then y times 5y is positive 5y squared. Y times positive 25 is positive 25y. Then you've got the 5 times everything. Negative 5 times y squared is negative 5y squared. Negative 5 times positive 5y is negative 25y. Then the last term, negative 5 times positive 25 is negative 125. And of course, the positive 5y cancels out with the negative 5y, positive 25y with the negative 25y, and away you go. You've got the y cubed time to minus 125. Now, what if it were the opposite, by the way? What if it were, let's say, x to the third, instead of being minus something with a cubed root, it would be plus, like plus 8, let's say. That you could do also, by the way. That you could do, again, it would be x, instead of being plus 2, instead of 5, it would be 2, because the third root of 125 is 5, third root of 8 is 2. So it would be 8x plus 2. And then on the other side, it would be x squared. Instead of plus the middle term, it would be minus the middle term. And the middle term would be 2x. And then the last term would be positive 4, because 2 times 4 is 8. And again, it would work the same way. If you multiply out everything, everything would cancel out except for the first term, which is x times x squared, which is x to the third, and the last term. The middle terms all cancel out. Again, you just got to kind of try a few of these. That's the only real way to remember them, because I mean, it's the easiest. It's not the only way. There are ways you can remember the rules, but I think trying them a few is the easiest way to do it. Okay, the next example is something similar to problem number 1, but it looks a lot more complicated. It's not really a lot more complicated, but it looks a lot more complicated. And we've got a trinomial here, so let's try 2 binomials. What two things multiply up to 36x squared? Well, we know x and x get you x squared. What gives you 36? The answer is 6 and 6. So let's do this as 6x and this as 6x. That's going to together multiply up to positive 36x squared. Now, we've got a positive as the last term. So we're going to have we're going to have both negative. Remember, just like with number 1, the last number was positive and the middle was negative. So in order to multiply up to two negatives, you're going to need a positive. In order to multiply up to a positive, you're going to have two negatives. That's negative here and a negative here. And then you have to figure out, okay, what multiplies up to 49? And clearly there's only one answer so far. There's only one answer that gets to 49, and that's 7 and 7. So we know right away it's going to be 7 and 7. Now, they have to add up to 84, but remember, because there's a 6 over here, they each get to count 6 times. So each 7 gets to count 6 times, and 6 times 7 is 42. So overall, they do add up to negative 84. This is, if you multiply it out to check it, 6x times 6x is 636x squared. Outer is negative 42x. Inner, also negative 42x. And last is positive 49, because it's negative 7 times negative 7. And that equals up to this number altogether when these two middle things are combined. Essentially, instead of it's really the same thing as problem number 1, except that instead of just plain x squared, necessitating plain x and plain x, you had 36x squared necessitating 6x and 6x. And that gave you something, an expression that was a little more complex, but it's the same basic idea. All right, number 4. Number 4 is really the same basic idea as number 3. So instead of being x and x to give you x squared, well, this is 25x squared, so we're going to do 5x and 5x. Now, there's no middle term, which means, as we saw before, this is the difference of two squares, which means one of them is going to be positive and one of them is going to be negative, and they're going to be the same number. Remember, the middle terms get wiped out if you have the same first expression and the same last expression with one positive and one negative. So what two numbers multiply up to negative 9? And of course the answer is positive 3 and negative 3. If you multiply it out, 5x times 5x is 25x squared. Outer is negative 15x. Inner is positive 15x. And last is negative 9. The middle two cancel out, and away you go. The only difference between 3 and 4 is in 3 there was a middle term. Number 4 there wasn't a middle term. Whenever there's no middle term, like we saw before, x squared minus 100, well, that's going to give you x plus 10 and x minus 10. Didn't take very long to figure that out because I realized right away that the middle terms get wiped out, which means the difference of two squares. First term and second term are the same. The only difference is the signs. And the second term, the only thing that multiplies up to 100, the only two numbers that are the same and multiply up to 100 are 10 and 10. Number 5 is an example of where we can try to factor both expressions, the top and the bottom, and see if we can usually what will happen is you'll be able to wipe out or cancel one of the expressions. So let's factor out the top, and then let's factor out the bottom. Okay, top is x squared plus 2x minus 3. So let's do two binomials, as we're always going to do in this situation. X squared gets you x and x. Now, this is a negative over here, which means one is going to be positive and the other has to be negative. Now, we need two numbers that multiply up to negative 3 but add up to positive 2. Now, the only two things that multiply up to 3 are 3 and 1. Well, we need a positive 2, so we're going to give the 3 to the positive and the 1 to the negative. That adds up to positive 2, because positive 3 and negative 1 multiplies up to negative 3. Now let's try the bottom. Same idea. Okay, x and x, just like the top. Now this is a positive number, and this is a negative, so that means they both have to be negative. So we need two numbers that add up to negative 3, multiply up to positive 2. And of course the only possibility is 2 and 1. If you put a 2 here and a 1 here, well, they multiply up to negative 2 and positive 2. Negative 2 times negative 1 is positive 2. And they add up to negative 3. Negative 2 minus 1 is negative 3. Now, if you notice here, they've got the exact same term in the numerator and the denominator, so you can wipe out this term. This term cancels, and your final answer, your simplest answer, is x plus 3 divided by x minus 2. Now, unfortunately, you cannot cancel the x's, because you can only cancel a term if it's being multiplied by something else, not if it's being added. So you'd have to leave it like this, and this would be your final answer. Homework 4 is about solving for the variable. Regular, non-quadratic equations. Of course, what you need to do in this sort of situation is isolate the variable, and then whatever number you have on the other side is your answer. Since this is an m over here in question number 1, first thing you got to get rid of is this other term, so subtract 17 from each side. So you've got 3m equals 77 minus 17, which is 60. Then you need to get rid of the 3, which is being multiplied by the m, so we can divide each side by 3 in order to cancel that, and you have m equals 20. The second one's a little more complex, but the first thing you need to do is multiply it out to get rid of the parentheses. So distribute the 2 times x minus 1, so 2 times x and 2 times negative 1. So 2 times x is 2x minus 2 plus 3 equals x, and then we can distribute the negative 3. So negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. When you have situations like this, the first thing you want to do is combine what you can combine. So on the left side, for example, we can say 2x, and then combine the negative 2 and the positive 3 into positive 1. And on the left side, we can do negative 3, x minus 3x, which is negative 2x, minus 3. Now we've got letters on one side. We want to try to get letters on one side and numbers on the other. So we can move the x's to the left side and the numbers to the right side, or vice versa. It really doesn't matter. But let's try to keep things positive, so to speak. Yuck, yuck. By adding 2x to this side to get rid of this term, add 2x to this side to get rid of this term, and now we've got 4x on this side. And as far as the 1, we can subtract 1 to get rid of it from this side, so we can subtract 1 from this side as well. You can do anything you want to one side of an equation as long as you do the same thing to the other. Negative 3 minus 1 is negative 4. Now we can simply isolate the x by dividing each side by 4. Remember, this is 4 times x, so divide by 4 cancels it. And we've got x equals negative 4 divided by positive 4, which is negative 1. Number 3 is a little bit of a crazy one that's really designed to just give you some practice. I'm not going to give you something this complicated on an exam, but it gives you a lot of practice of opening up expressions and manipulating algebraic expressions. Here we've got some brackets, which actually is what you do when you have a parentheses outside of the parentheses. In this situation, you want to work from the innermost parentheses outwards. So you want to try to open up the inner parentheses if you can. So let's start by opening up these inner parentheses over here. Negative 3 times y plus 2. So this becomes negative 3y, because negative 3 times y is negative 3y. Then negative 3 times positive 2 is negative 6. Let's open up this parentheses over here, again trying to get rid of the brackets. So the 5 times y minus 1 becomes 5 times y minus 5 times 1, which is 5. So let's take a look now at trying to write it over with these things open at least. We've got the 25 still. We've got the minus. Now we can use parentheses instead of brackets, since we now just have the 2y plus 5y minus 3y minus 6 equals, and while we're at it, let's open up this one here. So negative 3 minus, negative 3 times 2y is negative 6y. Negative 3 times negative 5 is positive 15. And then subtract this entire parentheses. 5y minus 5 minus 3y plus 3. All right. Let's combine what we can combine to start with. Let's work with the parentheses first, again with PEMDAS, with the order of operations. Let's work within the parentheses first. So let's keep the 25 where it is. 2 and negative 6 combine to negative 4. 5y minus 3y combines to positive 2y. See, getting a lot more manageable now. And on this side, we've got negative 6y plus 15 minus, and the 5y minus 3y becomes positive 2y. And the negative 5 positive 3 becomes negative 2. Now we got to open up the parentheses over here. And the way to open up parentheses that are being minused, you don't actually have to subtract, you don't have to actually multiply anything. So the way to open up the parentheses that are being subtracted is just change all the signs in the interior. So it's 25 minus negative 4, which means positive 4, minus positive 2y, which is minus 2y, equals, on this side, we've got negative 6y plus 15, which we haven't touched in a while, that's fine, minus 2y, minus negative 2, which is positive 2. Okay, now let's combine whatever we can combine. 25 plus 4 we can combine into 29. We have to leave the 2y by itself. On this side, we've got negative 6y, and negative 2y becomes negative 8y, and the 15 and the 2 become positive 17. Now we want letters on one side, numbers on the other. Let's try letters on the left, numbers on the right, although it will work just as easily on the other side. So we want to get rid of this whole term, and the way to get rid of this whole term is to add 8y to this side. Whatever you do to this side, you got to do to the other side too. And subtract this entire term, minus 29, minus 29. And now you're going to have numbers on the right, letters on the left. Negative 2 plus 8y, negative 2y plus 8y is positive 6y, equals 17 minus 29, which is negative 12. And now you just simply need to isolate the y by dividing each side by 6. And you have y equals a relatively simplistic negative 2. Again, this is just some practice to get used to the idea of manipulating algebraic expressions, but hopefully you won't see something quite this complex on an exam. Number 4 is a problem that has denominators, which whenever you're solving an equation, the first thing you want to try to do is get rid of denominators. Denominators are very hard to work with. Now, the way you can get rid of denominators is by multiplying each term by something that is going to cancel out the denominator. And in order to do that, you need to find what is called the LCD, or the least common denominator. Now, in this case, you can do a little bit of trial and error. What goes into 8, 4, and 6? Well, 16 goes into 8 and 4, but not 6. 12 goes into 6 and 4, but not 8. So if you do a little trial and error, you'll realize that the least common denominator in this case is 24, which goes into 4, 8, and 6. So you can multiply each term by 24. So remember, you can do anything you want to one term as long as you do it to the other terms as well. That's the great thing about algebra. So you've got this term, 24 times this. Then you've got 24 times 3 over 8 plus 24 times x minus 5 divided by 4. Okay, so now we can start canceling, and these are all going to cancel. 24 divided by 6 is 4, so you can cancel this, make this into a 1, which gets rid of the denominator, and make this into a 4. Over here, 24 divided by 8 is 3, so this becomes a 3, and that gets canceled. And over here, this becomes a 6, and that becomes a 1 because 24 divided by 4 is 6. So what you're left over here, everything else is canceled except 4 times x plus 3. Don't write 4x plus 3 because it's 4 times the entire term. It's 4 times the entire x plus 3. This next term, you've only got a 3 times 3 left, which is simply 9, plus, and now you've got 6 times the entire x minus 5. And from here, open up the parentheses and solve like we did before. Distribute the 4, which is 4x plus 12, equals 9, plus 6 times x, 6x, 6 times negative 5, negative 30, and combine what you can combine. So you've got 4x plus 12 equals 9 minus 30, which is negative 21, plus 6x. And so now we can again move the numbers to one side, letters to the other. Historically, we've always been doing letters to the left. And then we can move the number to the right. So you got 4x minus 6x is negative 2x equals negative 33. Divide each side by negative 2 to isolate the x. And what you have is x equals positive, because it's a negative divided by a negative, 33 over 2, or you can write it as 16.5, which is 33 divided by 2. Number 5 is a similar problem to the one that we've looked at before, much easier than number 3, and really all you need to do at the first step over here is open up the parentheses to start. So we can leave the 8x as it is. Now this becomes negative everything in the parentheses. So negative 3x, negative positive 2 is negative 2, plus 10 equals 3x, okay? Combine what you can combine, 8x minus 3x, 5x, negative 2 plus 10, positive 8 equals 3x. Now we want the letters on one side, numbers on the other. We've already got the numbers on this side, so maybe we can get rid of this term to get the letters on the other side. So subtract 5x from this side too. And we've got 8 equals 3x minus 5x, which is negative 2x. To isolate the x, we can divide each side by negative 2. And we've got x equals 8 divided by 2, which is negative 4. Obviously, it makes no difference whether the x is on the left or the right. Number 6 is a word problem. And in preparation for number 7, which is a little bit of a harder word problem, what I always recommend with word problems is to start with what's called a let's statement. And a let's statement tells you, it defines what your variable is. Now, in this case, what we're looking for is a number. So all we have to say is let x, let's say, for example, equal the number. Now, it may seem irrelevant or unnecessary in this case, and it probably is, but it's a lot easier when you've defined your term and when the problems get a little harder. So let's look at how this works in algebra. 3 times a number, well, we know that x is the number, and 3 times the number is 3 times x, which is 3x, decreased by 22, which means subtract 22, that's what decrease means, is, which always means equals 5. Find the number. Let's solve this. This obviously is very simple. Isolate the 3x by taking the 22 out. So we've got 3x equals 5 plus 22, which is 27. Isolate the x by dividing each side by 3, and you've got x equals 9. And that's our number. Number 7 is a little bit of a more complicated word problem. Here you're choosing between two health clubs. Club A has a higher membership fee, but a lower monthly fee, and Club B has a lower membership fee, but a higher monthly fee. $40.25 monthly versus $15 to sign up and $30 altogether, and then they want to know, or we want to know, how many months will the total cost of each club be the same? And then what will be the total cost for each club? Now, we know the monthly cost. We know the upfront costs. What don't we know? The only thing we don't know that we need to solve this problem is the number of months. So that's why let statements are important, because we have to define them properly. So let's say let x be the number of months. That's the only variable, if you think about it, that we really don't know over here. So let's try to figure out cost A, or the cost of Club A cost, and equal that, because we want them to be the same, equal Club B cost. So let's put two sides of the equal sign, and let's try to put the Club A cost over here, and the Club B cost over here. So for Club A, we know it's a membership fee of $40, plus every month it's $25. So it's 25 times the number of months, which is 25 times x. Club B starts with 15 and adds how much for each month? 30. So it's 30 times x. You see why that works? Because x is the number of months. So it's 25 times the number of months for Club A, and 30 times the number of months for Club B. Once you have that, now it's a very simple equation to solve. Let's say, get rid of the x term from this side, and do negative 30x, and the number term from the other. Just because we've always been doing letters on the left, numbers on the right. So 25 minus 30x is negative 5x. 15 minus 40 is negative 25. isolate x by dividing by -5, divide by -5, and you've got x equals -25 divided by -5, which is +5. So what is this? Okay, so we've got 5. Well, our let statement told us that x is the number of months. So that means the answer to our first question is 5 months. What's the second question? What's the total cost for each club? Well, let's see. They should be the same. Let's figure it out. This is 5 months. So for club A, we've got 40 plus 25 times 5. 40 was the startup fee, and 25 each month. 25 times 5 is 125, plus 40 is 165. And for club B, this had better be 65 also. 15 plus 30x, 15 plus 30 times 5. Well, 30 times 5 is 150, plus 15 is also 165. Very good. Okay, our last problem over here is also a least common denominator problem. And the good news is you've only got 2 denominators, and they're the same. They're x minus 2. So if you multiply everything by x minus 2, you're going to get to cancel all the denominators. So our LCD is just simply x minus 2. So let's do x minus 2 times 2 over x minus 2 equals, again, x minus 2 times x divided by x minus 2. And you have to do it to the last problem also. So that's 2 times x minus 2. Everything's got to be multiplied by x minus 2. So of course this cancels with this. Same term, this cancels with this. And what you have left over is just a 2 over here on the far left equals x is the only thing that's left on this term, minus 2 times x minus 2. Now we can open the parentheses to get you 2 equals x, minus 2 times x is negative 2x, negative 2 times negative 2 is positive 4. So we've got 2 equals x minus 2x, which is negative 1x, plus 4. Subtract 4 in order to isolate the x. So we've got negative 2 equals negative x, and we can multiply or divide each by negative 1 in order to get rid of the negative x. Just flip the signs, and you have x equals positive 2. That would be your answer. The problem is, as I discussed in the original expression, is that if you try to check it, if you take one look at it, you'll see that this is not possible, because the denominators would be 0. The denominators here, x minus 2 and x minus 2, would be 2 minus 2 would be 0. And because this does not check, because that would be an undefined check, there is no answer. So the actual answer to this question is that there is no answer. It's a null set. But if you solved it properly, it would be negative 2, but that's sometimes why you got to check it to make sure that there are no zeros in denominators, because zeros in denominators cannot exist. They're undefined. Homework 5 is about quadratic equations and solving quadratic equations. Now, quadratic equations have many different ways to solve them, and so in the Homework 5, we ask you to do it in 3 different ways. Number 1, by factoring. Number 2, by the quadratic formula. And number 3, by completing the square, or the square root property. Now we're going to start by factoring. Now factoring, the way you need to do it is to factor it into 2 binomials and then to solve each one individually. Now the first thing you have to do with pretty much every quadratic equation, well maybe not every, but most quadratic equations, is to set the entire thing equal to 0. So in this one over here you've got an equals 8, so the way to get that equal to 0 is to simply get rid of the 8. And the way you get rid of the 8 is by subtracting 8 from this side, which means you got to subtract 8 from this side. So it means you got the 3x squared minus 2x, remember they're different variables so they can't be combined, minus 8 equals 0. Now you can factor into 2 binomials. Since we've got a 3x squared over here, the only way to get that in with the first 2 terms is to use a 3x and an x, because that's the only thing, those are the only 2 terms, both containing x's, that are going to get you to 3x squared. Now, because this is a negative, it means we're going to have 1 plus sign and 1 negative sign, which means we're going to need 2 numbers that multiply up to negative 8 and add up to -2. However, it's important to realize that whatever is over here is going to get counted double, because remember, when you FOIL it, the outer means this gets multiplied by this for the middle term. Now, of course, when you're talking about, so you really need to do a little bit of trial and error to figure it out. Now, of course, multiplying up to 8, there are only two possibilities, 4 and 2, or 8 and 1. And 8 and 1 I don't think is going to work. And if you do a little trial and error, you realize the only way to do it, for this to be a -2, is if you make this into a -2, and this into a +4. And the reason why that works is because, well, they multiply up to -8, because it's 4 and -2, which is -8, and they add up to -2 because the one over here counts 3 times because it's opposite the 3x. So -2 times 3x is -6x, and then the inner would be +4x. So overall, you'd get -2x, and that's why they work. Of course, you could check it to make sure it works. 3x plus 4 times x minus 2. If you FOIL it out, you get 3x times x, which is 3x squared. Outer is -6x, inner is +4x, and last is -8. And these two combined, the middle two combine to get this, which is of course the same thing as we had originally, so it checks out. Once you have this, now you can divide them. Each side is equal to 0. Since anything multiplied by 0 equals 0, the whole expression becomes 0 if either term is 0. So each one is equal to 0. 3x plus 4 equals 0, and x minus 2 equals 0. And so for this, you can solve it like you would any other equation. Subtract 4 from each side, and you've got 3x equals -4. Then divide each side by 3, and you've got x equals -4/3. That's one answer. Sorry, I didn't have room for it on the left side. And on this side, you just add 2 to each side, and you have x equals 2. So our two answers are x equals 2 and x equals -4/3. Both of them, if you plug it back in, I'm not going to do it, but if you plug it back in, both of them will work to solve the problem. Either of these will work. Okay, let's try number 2. Number 2 is similar. X squared minus 3x minus 10 equals 0. This is actually a little simpler. Well, it's already equal to 0. So use two binomials. Since it's x squared, you've got x and x. Now this is a negative number, which means the signs have to be split. And we need two numbers that add up to -3 and multiply up to -10. And again, if you do a little bit of trial and error, you'll realize pretty quickly that 5 and 2 work. -5 and +2 work. And so you split that because -5 and +2 add up to -3 and multiply up to -10. So you got x plus 2 equals 0, x minus 5 equals 0, and on this side you've got x equals -2, and on this side x equals 5. If you want to check it just to make sure, we didn't do this last time, but we'll do it now. The original equation was x squared minus 3x minus 10 equals 0. So let's try -2 first. -2 squared minus 3 times -2 minus 10 equals 0. -2 squared is +4. -2 times -2 is +4. -3 times -2 is +6. Minus 10 equals 0. And of course that works because 4 plus 6 is 10. Minus 10 is 0. And now we can try it with 5. 5 squared minus 3 times 5 minus 10 equals 0. 5 squared is 25. Minus 15 minus 10 equals 0, which of course is true. Numbers 3 and 4 ask you to solve using the square root property. And the square root property is simply based on the idea that if you take the square root of an x squared, it will give you x. So you can use that method to solve the problem. When it works, this is actually the simplest method to do it. The way you do this is very simple. 3x squared minus 3x squared equals 27. So you would need to isolate the x squared, and of course, like any other equation, divide each side by 3 to isolate the x squared. Equals 9. Now you take the square root of x squared, that's going to give you just plain x. So whatever you do to one side, you got to do to the other side. And the answer here, well, the square root of 9 is 3, but remember it's plus or minus 3. It could be +3 or -3 because anything that is a negative number multiplied by itself will give you a positive number. So the answer is plus or minus 3. So there are actually two answers. One is x equals 3, and the other is x equals negative 3. If you write plus or minus 3, that's fine also. But if you just write 3, you don't get full credit because you haven't completely answered the question. Okay, next one. Here is also a similar idea. In order to, there are really a couple of ways to solve this. You can multiply the whole thing out, and like we did before. You can multiply this out in two binomials and then combine everything, and you can do it that way. But a much simpler way to do it is to get rid of this exponent, get rid of this squared. How do you do that? Well, very simple. Take the square root of this whole side, and then you're left with 3x plus 2. And of course, whatever you do to this side, you do to that side too. So you got the square root of 9. The only thing is that you have two different possibilities. You've got positive 3 or negative 3, as we discussed. So you've got two different answers, and just like most quadratic equations, you're going to get two answers anyway. So here you've got two different possible equations. You've got 3x plus 2 equals positive 3, and you've got 3x plus 2 equals negative 3. And we can solve for each one of them separately. So on the left side, subtract 2 from each side. So you've got 3x equals 1. Divide each side by 3 to isolate the x, and you've got x equals 1 over 3. That's one answer. And on the other side, we can subtract 2 from each side, and we've got 3x equals negative 5. And again, divide each side by 3, and we've got x equals negative 5 thirds. Either one, of course, is the correct answer. If we plugged it back in, I'm not going to do that, but if you plugged it back in, you would get the correct answer as well. In case you're curious, by the way, just to show you, I'll use a different color, but just to show you that it would work the other way too. Let's say we wanted to do it the long way. We had 3x plus 2 squared equals 9. So we can multiply it out. We could FOIL it. We could make this 3x plus 2 times 3x plus 2, which is the same thing as 3x plus 2 squared. So 3x times 3x is 9x squared. Outer is positive 6x, and inner is positive 6x all again, so we'll make it plus 12x plus 4 equals 9. And then to set it equal to 0, well, it would work, but it would, well, let's set it equal to 0 by subtracting 9 from each side. We've got 9x squared plus 12x minus 5 equals 0. And then if you'd factor it, well, it would be more complicated because you'd have to, I imagine, get 3x on this side and 3x on this side to multiply up to 9x. And then you'd need a 5 and a 1 in order to multiply up to 5. And this is positive, so we'll make the positive get the 5, and we'll make the negative get the 1. And does that work? Let's see. 3x times 3x is 9x squared. Good. Okay, 12x is positive 15x minus 3, so the middle term works also, and the last term also works. So this actually does work, and then of course you'd set this side equal to 0, 3x plus 5 equals 0, and this 3x minus 1 equals 0. And if you solve for this, you subtract 5 from each side, so you get, and then divide by 3, so you get x equals negative 5 thirds, and on this side you add 1 to each side, so you get x equals 1 third, which is of course the exact same answer as we got in using the other method. And the third method by which to solve a quadratic equation, or the third method that we're going to learn, is the quadratic formula. Sometimes factoring just simply doesn't work. Sometimes the other method, the square root method, simply doesn't work. So you need to remember the quadratic formula, and this will always work, but it's just a little bit more complicated. And unfortunately, you just have to memorize this. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a is the coefficient of the x squared, b is the coefficient of the x, and c is the constant, in other words, the regular number, assuming that everything is equal to 0. So if we wanted to use the quadratic formula for the first one, a would be 1, because there is no coefficient of the x squared, which means it's 1. The b would be 8, and the c would be 15. So let's use the quadratic formula. Negative b, or negative 8, plus or minus the square root of b squared, which is negative 8 squared, minus 4ac, 4 times 1 times 15, all over 2 times 1, because a is 1. And let's execute this. So we've got x equals negative 8, plus or minus the square root of negative 8 squared is positive 64, minus 4 times 15, which is 60, all over 2. And 64 minus 60 we can change to 4. And of course the square root of 4 is 2. It's plus or minus 2, but it's already plus or minus, so you don't have to put another plus or minus there. So it's x equals negative 8 plus or minus 2 divided by 2. So you've got two different possibilities. You've got negative 8 plus 2 over 2, and you've got negative 8 minus 2 over 2. Negative 8 plus 2 is negative 6 over 2, which is negative 3. And negative 8 minus 2 over 2 is negative 10 over 2, which is negative 5. So here are our two answers, negative 3 and negative 5. And by the way, this could have been factored also. If you notice, you could have done two binomials, 8 and 15, which is 5 and 3. So x plus 5, x plus 3 equals 0, x plus 5 equals 0, x plus 3 equals 0, and of course subtract 5 from each side, x is negative 5, subtract 3 from each side, x is negative 3, which gives you the same answers. So you see, it's like in this example down here, I don't think it's possible to factor, so therefore you have no choice but to use the quadratic formula. So let's use the quadratic formula. It's equal to 0, so we can establish that a is the coefficient of the x squared, b is the coefficient of the x, not 3, but negative 3, important distinction, and c is negative 4. So we've got x equals negative b, which is negative 3, which is positive 3, plus or minus the square root of b squared, negative 3 squared, which is positive 9, minus 4 times 3, which is a, times negative 4, all over 2 times 3, which is 6. So x equals 3 plus or minus the square root of, well, let's see, what's negative 4 times 3 is negative 12, times negative 4 is positive 48. So negative 4 times negative 4 is 16, 16 times 48. Either way, you get positive 48. So you have 9 plus 48, which is 57. Square root of 57 over 6. Now you can break this down. Let's see. Can you break down 57 into something that is a perfect square? And the answer is I don't think you can. 57 only goes into 19 and 3 are the only roots of 57, and neither of them are perfect squares. So there's pretty much nothing more you could do here, and so your answer is this: 3 plus root 57 divided by 6, or 3 minus root 57 divided by 6. Either way, that's the best answer that you can come up with. Homework 6 starts with absolute value and inequalities, and the first few questions are about graphing things on a number line. Now, in order to graph things on a number line, the first thing you have to do is you have to draw a number line. And a number line simply means a straight line. So let's draw this as a number line. And in order to make it a number line rather than just a line, you'd put, let's say, a 0 in the middle, and then the positive numbers would be to the right, and the negative numbers would be to the left. Obviously, ideally, you'd space them evenly, but, you know, that's not really critical. Okay, so in fact, I'm going to copy this number line down here since we're going to need to use this a couple of more times for questions 2 and 3. So we'll use this number line for questions 1, 2, and 3. So let's start with question number 1. We say express the intervals in a set notation and graph on a number line, -1 and 6. Now, when you have a parentheses over here, that's the lowest point that this series of numbers can go. And the open parentheses means it cannot actually be that number, whereas the bracket means it can actually be that number. So what this means is that the lowest in the number that this set can be is -1, and it cannot actually be -1. It can be a shade more than -1. It could be, -0.99999, and the highest it can be is actually 6. So for -1, we're going to use an open circle, and we use an open circle because it cannot actually be -1, even though that's the limit. For 6, we're going to use a closed circle, and we're going to use a closed circle because it can actually be 6. And then you draw a line in between here and here. Let me make the line a little thicker so it's a little bit easier to discern. So here is, it starts at -1, ends at 6, and the 6 is filled in, the -1 is not. Second one is very similar, starts at -2. This time this is going to be filled in because it's a bracket, and the other side is also a bracket, so we'll fill in the 5 as well. And then we'll take a line and we will draw it all the way from here to here. And if you're on a paper, you can make it a little thicker to make it a little obvious that it's the line. So that's fine. That's the easy enough answer to questions 1 and 2. Question 3 is slightly more complex, but not really much more complex. We're using the set. We're using a number line to find the set. In other words, to find what is the union, what is the intersection, what is the commonality of these two systems. So let's start with the first one, -3, 0, both parentheses. So -3 will make an open parenthesis, 0 will make another open parenthesis, and then we'll make the line in between them. Okay, and for the other one, maybe we'll use a different color to indicate, well, you can use the same color. To -1 and +2, and both of them are brackets, so both of them we're going to fill in. So -1 and +2, and then we will put in a line. And if you want to know what the combination is, well, the combination you can see right away. We'll use a different color for this one. The combination is from here until here. That's in both sets. If you wanted to actually draw the combination, you can make this filled in because this area, the -1, is in both sets. Up to 0 is in both sets, blank, because this one is blank, and then the line in between, and that would be your combination set. The next two problems are about solving equations and then using a number line to graph them. Now, solving an equation that is an inequality like this, rather than being an equal sign, there's an inequality, in this case a less than sign, in this case a more than sign. But either way, if you do it, you just simply solve like a regular equation. So let's say number 4, what do we got? We got 5x plus 11 smaller than 26. If it were an equal sign, then what you would do is you would simply solve for the x, so therefore because it's a smaller than sign, you still solve for the x. Get 5x by itself by subtracting 11 from each side, and you've got 5x is smaller than 15. Divide each side by 5 to isolate the x, and you've got x is smaller than 5. To draw that on a number line, well, simply let's grab another number line from up here. In fact, let's then do another one because we'll use that for number 5 also, and we'll put it over here. And to use the number line, well, we've got x is smaller than 5. Well, okay, so let's put the 5 over here. We're going to make a circle because it cannot actually be 5. And x goes in that direction, and we'll just put an arrow at the end. Doesn't matter how long this line is, because the arrow symbolizes that it goes on forever. In other words, what this tells you is that x is less than 5, but it goes on forever in this direction. X can't be 6, x can't be 7 off this chart over here, but it can be any of these numbers. It can be 2, it can be -1, it can be -4, it can be anything to that effect. Simple enough. Let's look at the bottom one. Now this is a little bit of a more complex equation, but it's the same idea. So we've got 8x plus 3. Now with any other equation, you first open the parentheses. So we'll keep the 8x plus 3 greater than, then we distribute the 3. 3 times 2x is 6x plus 3 plus x plus 5. Let's combine whatever we can combine. We've got 8x plus 3 on this side, nothing to combine there. And on this side, we've got 6x plus 1x is 7x. 3 and 5 is plus 8. Okay. Well, now let's get all the letters to one side, all the numbers to the other. Simple enough. Subtract 7x from this side for that to cancel. So subtract 7x from this side. Subtract 3 from this side to cancel, and subtract 3 from that side. And you've got 8x minus 7x, which is plain 1x. And x minus 3 is 5. So what you have is x is greater than 5. So same thing as the other one, except the opposite direction. X cannot be 5, but it can be more than 5. And now we've done this question, and that's our answer. The next section is absolute value equations. Now, absolute value equations are just like solving regular equations, except that absolute value can have a negative value or a positive value. So, for example, if I say the absolute value of x equals 5, well, x could be negative 5, in which case the absolute value of negative 5 is positive 5, or x could be positive 5. So in order to solve a simple thing like this, you have to open up the absolute value terms. You simply have to set x equal to the negative value of this side and the positive value of this side. So x could be positive 5 or x could be negative 5. Either way, that works. So to solve these equations are the same idea. You open up the absolute value, get rid of the absolute value term by setting two possibilities. One with the positive value of the thing on the right side and the other with the negative value. So let's draw a neat little line down the middle over here. We're separating them. We've got 2x minus 1 equals positive 5, but also the other possibility is 2x minus 1 equals negative 5. We're using both possible positive and negative indicators for the thing on the other side of the equation. Let's solve each one. That's easy enough. Add 1 to each side over here. So you've got 2x equals 6. Divide each side by 2 in order to isolate the x as usual. And you've got x equals 3. On the other side, well, add 1 to each side. So you've got 2x equals negative 4. And again, isolate the x. So you've got x equals negative 2. Both of these are correct answers. If you wanted to check them, plug them back in. Let's use the 3 first. 2 times 3 is 6, minus 1 is 5. So the absolute value of 5 is in fact 5, so good. Now let's try the other side. Negative 2 times negative 2 is negative 4, minus 1 is negative 5. And in fact, the absolute value of negative 5 is also positive 5, so that works as well. For number 7, we do the same thing. Now, when you're opening up the absolute value, you still have 3 times the entire expression. You've still got 3 times 2x minus 1. So on each side, you're still going to need a parentheses. So for example, on this side, you can say 3 times 2x minus 1 equals positive 21. And again, the reason for that is simply that you're opening up the absolute value, but it's still 3 times this entire thing. On the other side, it's also 3 times the entire thing. But this time, you're going to equal it up to negative 21. Okay, simple enough. Let's solve the equations. Distribute the 3 over here. 3 times 2x is 6x minus 3 equals positive 21. Isolate the 6x by adding 3 to each side to get rid of this over here. So you've got 6x equals 24. Divide each side by 6, and you've got x equals 4. That's one answer. Now let's try the other side. Distribute it in the same way. 6x minus 3 equals negative 21. Add 3 to each side, and you've got 6x equals negative 18. Divide each side by 6, and you've got x equals negative 3. Okay, for number 8, very similar. Same exact thing, as a matter of fact. Sorry, there's not a lot of room over here. You know what I'm going to do? I'm going to use a different color, and I'm going to solve number 8 over here. Let's do both on top of each other rather than on bottom of rather than next to each other as we did last time. Now, the first thing you're going to want to do over here is isolate this term. Isolate the term with the absolute value. You don't want to have to worry about this plus 7 over here. That's going to make things extremely complex. So let's get rid of the plus 7 term. And the way to do that is very simpler, to subtract 7 from each side. So you've got 4 times the absolute value of 1 minus 3/4 x equals 3. Now we can set each side equal to either positive 3 or negative 3. So 4 times 1 minus, and instead of 3/4 x, we can use 3x over 4 equals 3. And on the bottom, we can use the same thing, 4 times 1 minus 3x over 4. That just makes it a little easier, equals -3. Now, to solve any kind of an equation, the first thing you need to do is distribute. So 4 times 1 is 4. Then 4 times -3x over 4, well, the 4's cancel. If this 4 is being multiplied by this whole term, so this is on the denominator, this is the numerator, you can cancel out the 4's, and you're left with a plain -3x. And you're left with a 3 on this side. Once you have that, isolate the 3x by subtracting 4 from each side. That gives you the 3x term, and on this side it gives you 3 minus 4, which is -1. Divide each side by -3 to isolate the x, and you've got x equals -1 divided by -3, which is positive 1/3. Of course, a negative divided by a negative is a positive. And on the bottom over here, okay, simple, same idea so far. 4 times 1 is 4. 4's cancel, so you've got -3x equals -3. Now you again subtract 4 from each side to get rid of that term, and you've got -3x equals -7 this time. And then you divide each side by -3, and this time you've got x equals positive 7/3. And of course, if you check it and you plug in these terms back into the original equation, both of them will work. And you're just going to have to take my word for it, or try it yourself, because I'm not going to actually do it in this video. But that is how you solve absolute value equations. Okay, homework number 7. Here's where we get into some complicated equations, really. It's just some of the practice of the hardest stuff we've done so far. And the reason why the thing that makes this hard is you have a fairly complicated least common denominator. You've got denominators, so you got to get rid of them, and you got to find the least common denominator. Now, to find the least common denominator, the first thing you got to do is you got to factor this thing over here, because you got to look at its roots. You got to look at its terms. So to factor this was just something we did back in class 4, I think it was. You put it into two monomial terms. Okay, x and x. Now we need two numbers. This is a negative, so this is going to be positive and negative. We need two numbers that are going to add up to +1, because the middle term is positive x, which is positive 1x. And the last term is -6. And if you think about it, the only possibilities are 3 and 2. +3 and -2. Now the good news is that those are also the terms underneath the denominators for here. So the LCD, the least common denominator, is x plus 3 times x minus 2, because this whole term, this whole x plus 3 times x minus 2, will actually divide into each term. So let's try to do it with term number 1. Now with term number 1, and let's do this in different colors so it makes sense. For term number 1, x plus 3 cancels out with the x plus 3, which means the only thing you have left is the x minus 2. So it's 6, the top, times the x minus 2. In other words, it's this whole term times this whole term, but the x plus 3's canceled out. So this term is left with 6 times x minus 2. The second term, and we'll use a different color. This time it's the x minus 2 that cancels with the x minus 2, and you're left with only the x plus 3. So it becomes 5 times x plus 3. On the other side, well, you got x plus 3 cancels with x plus 3, and x minus 2 cancels with x minus 2, and you're left with simply -20 on top. And from here, it becomes much easier. From here, just distribute and multiply and solve. 6x minus 6 times 2 is -12. Minus 5 times x, -5x. Minus 5 times +3, -15, equals -20. Combine what you can combine. X minus 5x is x. -12 minus 15 is -27, equals -20. To isolate x, simply add 27 to get rid of the other term. Add 27. And x equals -20 plus 27, which is plain old 7. Let's apply the same logic to question number 2. Well, okay, we got an x and an x. Again, we're factoring. This is a negative, which means we know that the signs are going to be positive and negative. Now we need two that are going to add up to -2 and multiply up to -8. And if you think about it, the only ones that make sense, once again, are 4 and 2, with the 4 being the negative. -4 and 2 add up to -2, and they multiply up to -8, which means, similar to the previous question, the LCD is x plus 2 times x minus 4, because this will go into all of the other terms. Thankfully, these other two terms have the same expressions as the one underneath this fraction. Okay, so for the first one, the x minus 4 is going to cancel with the x minus 4, which means you've got the x plus 2, and you got 1 times x plus 2, which is just plain x plus 2. For the second term, you've got the x plus 2 canceling the x plus 2. The x minus 4 is the only one left, so you've got 5 times x minus 4. And on the other side, the whole thing cancels, so you've got just plain 6, because this cancels with this, and this cancels with this. Now let's distribute this parentheses. So you've got x plus 2, negative 5x, minus 5 times 4 is positive 20, equals 6. Let's combine. X minus 5x is negative 4x. And positive 2 plus 20 is positive 22, equals 6. Subtract 22 from each side, and you have negative 4x equals 6 minus 22, which is negative 16. Divide each side by negative 4 in order to isolate the x. Divide this side by negative 4, and x equals negative 16 divided by negative 4, which of course turns out to be positive 4. You know, let's check it. Why not? You know, let's just make sure. We got 1 over, well, that doesn't work, because then this is going to be a 0. So I guess just like we saw earlier in the course, that would actually not work, even though it is the answer. I mean, that's the answer that we got from solving it, but as it turns out, the whole equation isn't going to work because it's going to check as a denominator of 0. Number 3 is a little harder in that you have different terms on the different denominators. Now, we can still factor a little bit. You always want to try to factor everything. This obviously can't be factored. It's already in its simplest term. This can't be factored, but 2x plus 6 can be factored into 2 times x plus 3. You see why I'm doing that? I'm doing that because this I want to be similar to this. So our LCD, what will divide into everything? Well, first of all, you need a 2 times x plus 3, because that's necessary to divide into this fraction. But you also need the x minus 2. So this is actually the least common denominator. You have to multiply this whole thing by every term, because the x minus 2 is necessary to cancel out this. The x plus 3 is necessary to cancel out with this, and the 2 is necessary to cancel out with this. So now we're going to have to multiply this by each of the others. You know, if I had more room, maybe I'd do them separately, but let's just use different colors like we did last time. Okay, so the first term, the x plus 3 cancels with the x plus 3. And what do you got left? You got the 2 times x minus 2. So this is 3 times, I'll use a dot, 2 times x minus 2. Okay. Now let's use, for the middle one, well, the 2 times x plus 3 wipes out the 2 times x plus 3, and the only thing you got left is the x minus 2. So you've got 5, which is the numerator, times x minus 2, plus, now you got the last thing over here, and we'll use purple, I guess. The x minus 2 wipes out the x minus 2, but you still have the 2 times x plus 3. So I'll put this as 2 times x plus 3. All right, once you have this, you can solve it like you would any other equation. First of all, of course, 3 times 2 is 6. Well, you can open up parentheses first, but it really doesn't matter because this is multiplication, so you can make this into a 6. So 6 times x is 6x, minus 6 times 2, which is 12, equals, open up this parentheses, 5x minus 5 times 2, which is 10, plus 2 times x is 2x, plus 2 times 3, which is 6. And now combine them all. Well, on this side, you got nothing to combine yet. On that side, you got 5x plus 2x is 7x. Negative 10 plus 6 is negative 4. Now, let's say we can subtract 7x from this side and 7x from that side, and add 12 to this side and 12 to that side. So you've got negative 1x equals negative 4 plus 12, which is positive 8. And you can divide or multiply by negative 1 in order to get x into positive. Basically, you just got to flip the signs, and this becomes negative 8. Completing the square is a method for solving quadratic equations that we didn't discuss much before. I've done it in the other video, but we didn't do it when we were discussing the previous homework on quadratic equations. But this is a mechanism by which we try to solve an equation, not necessarily by using the quadratic formula, which is pretty complicated, and it's a situation where you can't factor. If you can factor, then just do that. Obviously, that's much simpler. But completing the square is a way that we get it so that whatever's on this side, whatever's on the quadratic side, will become two monomials that are the same. Or in other words, two binomials that are the same, two binomials that are squared. And that will allow us to use the square root property in order to get the answer. So, for example, over here, what you need to do is really just take 1/2 of whatever this coefficient is, 1/2 of that, and multiply it by 2, and make whatever is multiplied by 2. Take 1/2 of that, square it, square it, and then you make sure that number's over there. So 1/2 of negative 8 is negative 4. Negative 4 squared equals 16. So if 16 is over here, then we know we're going to be able to divide it into two binomials that are the same as each other. Let's show you how. First of all, if we had x squared minus 8x plus 16, watch how we could factor that. We could obviously do x and x. Because this is positive and this is negative, they're both negative. And of course, 16 is 4, and 4 times 4, and negative 8 is negative 4 plus 4. So they both become 4s. Obviously, that's what will always happen. If you take half of this and you square it and put that over here, by definition, it has to be two of the same binomials. And once you do that, by the way, the whole point of this is x minus 4 times x minus 4 is the same as x minus 4 squared. And that makes it a lot easier to use the square root property, as we'll see. So first of all, how do we get this to be a 16? Well, that's easy enough. Just add 11, right? And if you add 11, you can do that. Remember, you can do that in any algebraic equation as long as you do it to the other side too. You do it to this side, so do it to that side. Now we've got x squared minus 8x plus 16 equals 11. This can now be factored into x minus 4 times x minus 4, which we did on the other side, equals 11. This, of course, becomes x minus 4 squared. Same thing, same exact expression. In order to get rid of a square, all we have to do is take the square root of the whole thing, right? Take the square root of this whole thing, take the square root of this whole thing, and you've got x minus 4, because the square root of something squared is just that, equals square root of 11. And to isolate x, just simply add 4 to each side, and x equals the square root of 11 plus 4. The point of doing this is that if we use the quadratic formula, remember that negative b plus minus square root of b squared minus 4ac all over 2a, we get the same answer, but this is a little simpler. You know, once you can get past that initial hurdle of making sure that you know what to get over here, then using the square root property is going to be a lot easier than applying the quadratic formula. This is a complicated one, a little bit of a tricky one, probably more complex than anything you're going to see on the exam, but I think it's still good practice if you've looked at it and tried to figure out what to do, how to go about doing this. Well, whenever you talk about a quadratic, there's cubes and all that, but the first thing you always want to try to do for these kinds of things is see if you can factor anything out of all terms. And in this case, you can. You can factor something out of here, and that is you can factor an x squared out of each one. So you can say, for example, x squared times, and then this becomes 3x and the other side becomes 2. You can factor out 3x, x squared out of each one because there are at least 2 x's in each term. And on this side, you can factor out, well, let's see, you can factor out 4 from each one. So, because each thing can be divided by 4. 12 divided by 3 is 12 divided by 4 is 3, so this term becomes 3x, and this term becomes 2. I think you see right away that how this problem works, how this problem is going to tick, because you've got a 3x plus 2 on each side. Now, as with any quadratic equation, you want to set the whole thing equal to 0. So how can you set the whole thing equal to 0? The answer is you can subtract this entire term. Minus 4 times 3x plus 2 from this side, and minus 4 times 3x plus 2 on this side. Now, the interesting thing here is that because the x squared and the 4 have the same variable, in other words, they both have a 3x plus 2 next to it, you can change this is really the key to the question, into x squared minus 4 times 3x plus 2. Might take a little while to think of, and first of all, of course, this side becomes 0 because it's minusing the same thing as the original term. It might take a little while to think of why that is, but if you think about it logically, it makes a lot of sense because let's say you have 3x plus 4x. We know that's 7x because they have the same variable, that x. So let's say you have, xy plus 3y. Well, you can change that into, let's say, x plus 3 times y, because it's just the same variable, but you're adding. So x plus 3y. That's the same thing here. X squared times this minus 4 times this is the same thing as x squared minus 4 times this. Now, this can be further factored. X squared is the difference of 2 squares, with the missing middle term. So this is the same thing as x plus 2 times x minus 2, still times 3x plus 2 equals 0. Now, this time in a quadratic equation, we actually have 3 different possible answers. Any of these becoming 0 is going to make the whole thing 0, so we can actually divide this into 3 different sections. We can set x plus 2 equal to 0. We could set x minus 2 equal to 0. And we could set 3x plus 2 equal to 0. And for each one, we can get a different answer. Subtract 2 from each side, we've got x equals minus 2. Add 2 to each side, we've got x equals positive 2. And then subtract 2 from each side, and we've got 3x equals negative 2. And then divide each side by 3 to isolate the x. And we've got x equals negative 2/3. Any of these 3 answers will actually work if you plug it into the original equation up here. I don't know if I want to try this one over here because that's going to be really complicated. If we try the 2's, well, 2 cubed is 8. 3 times 8 is 24. 24 plus 24, well, 2 squared is 4 plus 8 equals 12 times 2, which is 24, plus 8, which is obviously the same terms. If you do it with a negative 2, it's going to be the exact same thing because negative 2 cubed or negative 2 squared is going to be a, well, actually, they're going to be a little different, but they're going to work. If we do a negative 2, so let's use a different color. If we do a negative 2, so negative 2 cubed is negative 8. Negative 8 times 3 is negative 24. Plus negative 2 squared is positive 8. Positive 4 times 2, which is positive 8. Then 12 times negative 2 is negative 24 plus 8. And again, obviously, these two sides are the same thing. And if you did it with negative 2/3, it would work as well. But that, again, you're just going to have to take my word for it. OK, let's try our last homework for this set, for number 7. That's the square root of x plus 3 equals x minus 3. Seems simple enough. Well, how do we get rid of a square root? Well, in equations, whenever you're doing one thing, you want to get rid of it, you just do the opposite. So what if we say the whole term squared? Well, the square root of something squared is the original term itself. Whatever you do to one side, you do to the other. So now we've got the square root of x plus 3 squared, which is just plain old x plus 3, equals x minus 3 squared, which means x minus 3 times x minus 3. this is going to be a quadratic equation because you have to multiply it out. No way you can solve this off the bat. You got to multiply the x minus 3 out and then set the whole thing equal to 0 and work on it that way. So do the FOIL. X times x is x squared. Negative 3x is minus 6x. Again, the outer is negative 3 times x is negative 3x. Inner is negative 3x again. So that's negative 6x altogether. Positive 9 for the last. Okay. Well, now it's a quadratic equation, so let's set the whole thing equal to 0. So let's subtract an x from this side and subtract a 3 from this side to cancel them. So we'll subtract an x from here and subtract a 3 from here. And let's do the opposite side, just to make it look a little bit more normal. On this side, we'll do the x squared. Minus 6x minus x is negative 7x. Let's see, this is positive 6 equals 0. Now, does this factor? It looks to me like it does factor, just off the top of my head. We've got an x and an x, and we've got a positive here and a negative here, which means both of these have to be negative. And it looks like 6 and 1 will work, because 6 and 1 multiply up to positive 6, and 6 and 1 add up, when they're both negative, to, of course, negative 7. Set each equal to 0. And on this side, x equals 6. And on this side, x equals 1. And there you have it. Homework number 8 is actually a fairly easy homework relative to number 7 and relative to some of the ones that are upcoming. The first part of homework number 8 is about domains and ranges. Now, domains and ranges are the province or the part of the course that deals with functions. Functions are whenever the domain, which is the independent variable, affects the range, affects in science, what we would call a dependent variable. For example, if I say if y equals x plus 3, this is a function because whatever x is determines what y is. And in fact, x is a function of y and y is a function of x. They both determine each other. As, you know, when x is 1, y is 4. When x is 10, y is 13. When x is 100, y is 103, etc. You could also write this, that f of x equals x plus 3 because y, or written as f of x, means a function of x, which it clearly is. Y is a function of x. You could also write this, by the way, y equals a function of y plus 3, because of course this is also dependent on the y. If y is 103, then f of y is 100. If y is 6, then f of y is 3, etc. A function is when one value is dependent on another. When a domain is the initial part of the series of the expression, and the range is the thing that's dependent on the initial part. When you have a series of ordered pairs over here, the domains are the first ones, and the ranges are the last ones, the y values. The x values in the ordered pairs are the domain, and then you have the range. So for example, in the first one, the domains are 1, 3, and 5. That's this, this, and this. And the ranges are 2, 4, and 5. Basically, 1 leads to 2, 2 leads to 3, and 5 is to 5. And they are functions unless you have two of the same domains leading to different values in the range. In this case, you don't have that. All the domains are different, and of course, so this is a function. The second one, on the other hand, is not a function, and let's see why. You've got 5, 6, you've got 5, 7, you've got 6, 6, and you've got 6, 7. And this is so, the domain essentially is 5 and 6. That's really your whole domain. It could only be 5 or 6, and your range could be 6 or 7. But it's not a function, and the reason is because the same domain can lead to two different ranges. A 5 can lead to a 6, and a 5 can lead to a 7, which means the domain is not determining the range. The domain is not telling you what the range is, because the domain could be the same and come up with different ranges. In order for something to be a function, that means that if I know the domain, I know the range. Well, that's not true over here, because over here, even if I know that the domain is 5, the range could be 6, or the range could be 7. So this is not a function. The next one, let's see, 10, 4, negative 2, 4, negative 1, 1, 5, and 6. This is a function. They might say, well, hold on a second, you have two of the same ranges. That's okay. You can have two of the same ranges coming from different domains. You just can't have two of the same domains leading to different ranges. And the reason is, remember, the idea of a function is if you know the domain, you should be able to figure out the range. Well, that's true here too. If you know the domain is 10, you know the range is 4. You know the domain is negative 2, you know the range is 4 as well. That's okay, because the range is determined by the domain. So this is a function. And the last one, for the exact same reason, is also a function. If the domain is 4, the range is 1. If the domain is 5, the range is 1. Domain is 6, range is 1. Either way, knowing the domain tells us the range. So the only one that's not a function is number 2, because the same domain can give you different ranges. The next part of the homework asks you to figure out really plugins, really functions, by defining what the function is. We are told in number 5 that f of x is 4x plus 5. So now we have to figure out first the f of 6. Function of x is 4x plus 5. So what is a function of 6? So here all you have to do is just plug in whatever is in the parentheses over here for the x. So if f of x is 4 times x plus 5, so f of 6 is 4 times 6 plus 5. So a, you could say, is 4 times 6 plus 5. Now, of course, 4 times 6 is 24. Plus 5 is 29. Now, what about x plus 1? Okay, well, that means you have to substitute wherever you have an x for an x plus 1. So f of x is 4x plus 5, so f of x plus 1 is 4 times x plus 1 plus 5. See, all we're doing is taking this x plus 1 and putting it where the x was, over here. So distribute this. 4 times x is 4x plus 4, and then of course you still have the plus 5. You can combine the 4 and the 5, and you have 4x plus 9. And now you've got the negative x. Simple enough. Just take the, instead of 4x plus 5, it's 4 times negative x plus 5. Now 4 times negative x is negative 4x plus 5. Simple enough, right? This one is a little more complex, but not really that much more complex. Let's take a look at negative 1. Again, just substitute negative 1 for all the x's. So g of x, the fact that it's g and not f means nothing. Just execute it the same way. So that's negative 1 squared plus 2 times negative 1 plus 3. Again, all we did was substitute negative 1 for x. Negative 1 squared is positive 1 minus 2. Plus 3, which of course is 2. Second one, again, a little harder. Let's put this over here because this is going to be a little bigger. We're going to have to substitute x plus 5 for all the x's. So this is x plus 5 squared plus 2 times x plus 5 plus 3. Now we have to do this this is really x plus 5 times x plus 5. So we're going to have to FOIL it. X plus 5 times x plus 5. Again, first is x squared. Inner is 5x. Outer is 5x, so the total is 10x plus 25, which is the last. Plus, now we'll distribute the 2. So 2x plus 10 plus 3. What can we combine here? Well, we can't combine the x squared with anything, so let's just leave the x squared. How many x's you got? Well, you got 10x plus 2x. That's 12x. And then numbers, you got 25 plus 10 plus 3, which I believe is 38. Okay, and finally our last one is just negative x. Okay, simple enough. Negative x squared plus 2 times negative x plus 3. Okay, negative x squared is positive x squared. Same thing, because any negative squared is a positive, like negative 4 squared is positive 16. Plus 2 times negative x is minus 2x plus 3, and there's really no way to simplify this anymore. So that becomes your answer. Okay, let's go to the last part of the homework. And the first 6, 7, and 8 say determine whether each function is even, odd, or neither. Well, one way you can do this is simply by trial and error. There are ways you can do it in terms of rules, but you can do it by trial and error. Any number cubed, any number times itself, times itself, times itself, is, if it's even, it's going to give you an even number. If it's odd, it's going to give you an odd number, because the rule of multiplication is that even times even is even, odd times odd is odd, even times even times odd is even. For example, 5 times 6, odd times even, 30. 6 times 6, even times even, is 36, even. But 5 times 7, which is odd times odd, will be 35, which is odd. So this, anything multiplied by itself, if it's even, it is going to be even, because it's even times even times even, which is even, plus x, which is even, because it's the same number, obviously, which of course is going to give you an even number. What if it's odd, on the other hand? If it's odd, then this is an odd times odd times odd, which is going to give you odd, plus odd, and an odd plus an odd is always an even. So, 7 plus 5 is 12. 11 plus 17 is 28. Either way, you're going to get even. So this function, no matter what, has to be even. And interestingly enough, the same thing is going to be with this one. A number squared, if the number is even, well then even times even is even, minus to the 4th power, same thing, even times even times even times even is always going to have to be even. Even minus even, which of course is going to be an even number. And if they're odd, well, x squared is going to be odd for the same reason. X to the 4th is going to be odd for the same reason. And just like we did before, odd minus odd is also even. So both of these are going to be even no matter what. Okay. In terms of 9 and 10, we have to figure out the domain. The domain means you don't have to solve this or anything. I've seen people do similar things on homeworks and exams where they try to solve it, and this is very, very difficult to solve. It's actually impossible to solve because you have two different variables, and there's no real way to tell the two variables apart. But that's not what we're looking for. What we're looking for is, what can x be? Now, normally, if I just have plain x can be any number. X could be positive up to infinity, down all the way to negative infinity, and anything in between. It could be even, it could be odd, it could be negative, it could be positive, it could be a fraction, it could be exponent, it could be rational, irrational, it could be anything except for an imaginary number that it can't be. But we know certain rules. When you see a denominator, the first thing you should think of is, okay, what can a denominator not be? And the answer is a denominator cannot be 0. So what would make a denominator 0? Well, if x were negative 7, then this denominator would be 0. Negative 7 plus 7 would be 0. And this x also cannot be 9, because if x were 9, then this denominator would be 0. So if I ask you for the domain of each function, I would say x, so that x cannot equal negative 7, and x cannot equal 9. That is the domain of x. But x can equal any other real number. Doesn't have to be rational, doesn't have to be positive. X can equal anything except for 7 and negative 9. Down here, on the other hand, when you see square roots, the first thing you should think of is the idea of imaginary. A number, x cannot be an imaginary number. Unless there's an I there, you can assume that a number is real, which means that the number in the square root has to be positive. It cannot be negative. So what can x be? Well, x cannot be 0, because then 0 minus 3 is negative 3. X can't be negative, because then it's certainly going to be a negative number in here. X can't be 1 either. X can't be 2 either. X can only be 3 or higher. If x is 3, then you got 3 minus 3, and you have a square root of 0, and that's fine. If x, which is 0. If x is higher than 3, then the number in here is positive. So for the domain here, I would say x, so that x is greater than or equal to 3. And that's the domain. X is 3 or higher. And this is the way you symbolize higher, greater than or equal to. Homework 9 is graphing. And we've got 8 problems that we're going to graph. In the other videos, I show you how to do it, so I'm just going to kind of go through them. First thing we need to make sure is that the problem is in y equals mx plus b form. And fortunately, our first problem is. Now, when something is in y equals mx plus b form, the way I always recommend doing it is by making a little chart with an x and a y, and pick 3 arbitrary values for x. It could be 0, 1, 2. It could be negative 1, 0, 1. It could be 2, 3, 4. It really could be anything. It doesn't matter which 3 values. Put what does y equal? Now, in this case, y equals 3x minus 6. Substitute this number for the x to figure out what the y value is. 3 times 0 is 0, minus 6 is negative 6. 3 times 1 is 3, minus 6 is negative 3. And 3 times 2 is 6, minus 6 is 0. Let's plot our 3 points. 0, negative 6 is our first point, so that's 0, 1, 2, 3, 4, 5, 6. We'll plot it over here. 1, negative 3, that's 1, negative 3 here. And then 2, 0, which is here. These better be on the, that's why you do 3 to make sure they're on the same line. Otherwise, you could probably just do 2 of them. But if you want to make sure you're right, you should do 3 and make sure that they're on the same line. And then once you do, you take a straight edge, a ruler, or something like that. Draw a straight line going in both directions. And then you can put a little arrows over there. You can even write the equation, y equals 3x minus 6 on the line, and now you've got your equation. Congratulations. Now let's try number 2, and I'm going to get this out of here. Again, it looks something like that. Okay, let's get our new graph paper in there. Okay. Now number 2, unfortunately, is not in y equals mx plus b form. But that's okay. We just have to convert it into y equals mx plus b form. We want y to be on one side and the x term and the number term to be on the other. So in order to isolate this y term, let's get rid of the 3x first by subtracting 3x from each side. So you have 2y alone. Now on this side, of course, the 12 and the 3x can't combine. Let's put the x term first, because we want it in y equals mx plus b form. And you've got the 12 still the positive 12. Now you need to isolate the y. So in order to do that, you divide each side by 2. So you've got y equals negative 3 halves x. We'll call it negative 1.5x. Same thing. Plus 12 divided by 2, which is 6. Now we can make our chart. Truth is, we could have made our chart before, but I'd like you to get into the habit of doing everything in y equals mx plus b form. So let's say, what do we got? We got negative 1.5x plus 6. Let's try 0, 1, 2 again. Why not? Negative 1.5 times 0 is 0. And then, you're always going to have the y-intercept at 0, of course. That's going to be this number, the b, the y equals mx plus b form. This is the b. So in this case, this is the y-intercept. I'm sorry, whoops, down here. This is the y-intercept because now it's in y equals mx plus b form. And the reason why it's in the y-intercept is because that's what's going to happen when the x term becomes a 0. It'll make sense. All right, this is negative 1.5 plus 6, which is 4.5. And then you've got 2 times negative 1.5, which is negative 3 plus 6, which is positive 3. Let's plot them. 0, 6. 1, 2, 3, 4, 5, 6 up here. Okay. 1, 4.5. That's here. And then we've got 2, 3, which is here. Now let's get our little line drawing utility here. And let's draw it like this. There we go. And then let's go ahead and, make the arrows. And there you have it. That is our second line. 3 and 4 we're going to graph as well. I just realized in the homework that we're not going to actually have to graph all 8, just graph the first 4. The last 4 are about different issues. And So for this, we'll do the same thing as we did just previously. We'll turn it into y equals mx plus b form. How do we do that? Well, we got to isolate the y. How do you isolate the y? Well, you got to get rid of this negative x. How do you get rid of a negative x? Add x. Add x to this side, add x to that side. You've got y equals x plus 10. Graphing this should be extremely easy. We know the y-intercept is 10 from this. Well, let's see, it's x plus 10. That's the y. So when x is 0, 0 plus 10 is 10. Let's try, just for kicks, let's try negative 3 and negative 6. It'll work with any three numbers. You don't want to do anything too crazy, but let's try this. So you got negative 3 plus 10 is positive 7, and negative 6 plus 10 is positive 4. So let's plot our points 0, 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, way up here. So that's why I didn't want to go into the positive territory, because then it's going to go off the chart. Negative 3, 7, so the x is negative 3, 1, 2, 3, 4, 5, 6, 7. That's here. And then negative 6, 4 is here. And let us go ahead, grab our line utility, and let's draw the arrows. Before I was extending it, now I'm just going to leave it like this. That should be fine. Notice, of course, by the way, a slope of 1, because this is the coefficient of the x is the slope, and since there's nothing here, it's a 1. So for every 1 up, 1 over, 1 up, 1 over, 1 up, 1 over, etc., 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 with the y-intercept, of course, being positive 10. That's up here. Okay, let us try the next one. Let's get a new piece of graph paper here. All right, this one we can also turn into y equals mx plus b form. Let's go ahead and figure out how to do that. Well, first, let us get rid of this term. Remember, we want to get rid of the 7x term to isolate the y, so we can do add 7x to each side. So now we've got negative 3y equals 7x plus 21, because we want the x term to be first. To get rid of whatever's next to the y, we divide negative 3 from this, and then once we do it to one term, we got to do it to all the others. So we've got y equals 7 divided by 3, which is divided by negative 3, which is negative 7/3, or negative 2 1/3 times x, either way, minus 7. Okay, so now let us do our chart. We've got x and a y here. What do we got? We got negative 7/3 x minus 7. Because I have this, I got a 3 in the denominator, I want to go by 3s. So let's do 0, 3, and 6. You'll see that'll make it a little easier because it will allow us to cancel out the denominators. Okay, so now, of course, the 0 is anything times 0 is 0, minus 7. That's our y-intercept at negative 7. That's, of course, the b. Now, negative 7/3 times 3, the 3's will cancel, so this becomes negative 7 minus 7, which is negative 14. Oh, this is going to go off the charts. So I have an idea. Rather than have it go off the charts, let's make this into negative 3 and negative 6. That'll reverse it. Because if we multiply negative 7/3 by negative 3, so then it's a negative times a negative is a positive, the 3's cancel out, and this becomes positive 7 minus 7, which is 0. And this becomes negative 7/3 times negative 6 minus 7. This cancels with this. That becomes a 2. And this becomes negative 7 times negative 2, which is positive 14 minus 7, which is positive 7. So overall, we've got 0, negative 7. 1, 2, 3, 4, 5, 6, 7. We've got negative 3, 0. 1, 2, 3, 0 over here. And then we've got negative 6, positive 7. 1, 2, 3, 4, 5, 6, 7. Way up here. And our line is going to look like this. All right. Let's make our arrows, and there we go. And of course, notice the y-intercept. Of course, this is the negative 7. That's the y-intercept. The slope is negative 7/3, which means it goes down 7, down 3 for every 7 over. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Right. Down 7 for every 3 over. Yeah, it's rise over run. The y is the numerator. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 down. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 down. If the chart went that far. And for the last few, we just need to find the slope and the y-intercept. Now remember, as long as you have it in y equals mx plus b form, so the m is the slope, and the b is the y-intercept. So now the first one is already in y equals mx plus b form. So what's the slope? The slope is whatever's next to the x, which in this case is negative 3. That's easy. And the b, which is the y-intercept, is the constant over here, which of course is negative 7. That was extremely easy. Next one's also easy, but maybe not quite as easy. We need to isolate the y. You always want to isolate the y in order to get into y equals mx plus b form. To do that, get rid of whatever term is near it, which is the x, the 2x. So get rid of this by subtracting 2x. That cancels that. Now, just like we did before, we want the x term first in order to get into y equals mx plus b form. So we'll keep the negative 2x, which can't be combined with the 16. So you just got to leave the positive 16. Now we need to isolate the y. How do we isolate the y? Divide by whatever's next to it, which is a negative 4. And whatever you do to one, you got to do to all the others. So this cancels. And you've got y equals negative 2 divided by negative 4 is positive a half. 1/2 x, or 0.5x, either way. Or you can write x over 2. It's all the same thing. 16 divided by negative 4 is negative 4. So the slope is 1/2, or I'll write it as the decimal, 0.5. And the y-intercept is negative 4. Next one is similar. Subtract 3x from each side. Again, you got to isolate that y term. So you've got 4y equals negative 3x first, minus 12. Isolate the y by dividing everything by 4. And now you've got y equals negative 3x over 4, which is the same as negative 3/4 x. And I'm doing that because I want that to be the coefficient, obviously. And then negative 12 divided by 4 is negative 3. So let me make that clearer, our slope is whatever's next to the x, which is negative 3/4, and the y-intercept is negative 3. How about the last one? Is this in y equals mx plus b form? The answer is yes, it is in y equals mx plus b form. Now it happens to be the x is on the left, y is on the right, but that makes no difference. This is the exact same thing as saying y equals x. Well, what's the b? Well, there is no b, and so therefore, the b is what? The b is 0. This is really the same thing as this. X equals y is the same thing as y equals x plus 0. Now I'm just putting it there to clarify the fact that it really is y equals mx plus b form. So what's our slope? Our slope is the coefficient of x. Since there is no coefficient of x, that means it's a 1, not a 0, remember. It would be a 0, by the way, if you had, let's say, y equals 2 or something like that. Then there'd be no x term. So then the slope would be 0. But we don't have that in this case. And then the b, which is the y-intercept, of course, is 0. Okay, homework number 10. Here we're going to continue with graphing, and we are going to be working on getting equations from facts. Last time we had the equations and we just had to graph them. This time we actually get some clues about how the equation looks, and we're going to actually figure out the equation and then graph it. Okay, question number 1. Find the equation for a line with a slope of 3 that passes through the point 1, negative 3, and then go ahead and graph the line. Well, of course, we're always going to try to put all of these equations in y equals mx plus b form. So let me write that on top over here so we don't forget that. M, of course, being the slope, and the b being the y-intercept. Now, for number 1, we are told what the slope is. The slope is 3. We do not know the y-intercept, so the way we're going to calculate that is simply by using the point that we were given to plug it in. We know that every line is y equals mx plus b. Now, our slope is 3, that we know, and we can plug in these values to get the b. So for the y, we'll plug in negative 3, since we're given that. For the m, we will plug in 3, because we're given that also. We're given that the slope is 3. And for the x, we will plug in 1, because we're given that as an individual point, plus b. And now we simply solve for b. And so really we've got negative 3 equals 3 plus b, and subtract 3 from each side in order to isolate b, and you've got b equals negative 6. Subtract it from this side, subtract it from that side, you've got b equals negative 6. Which overall means that our equation is y equals mx, and the m we know is 3, plus b, and the b is negative 6, which gives you minus 6. So that's our equation. Now, we could graph this by using the same system as we did before, making the charts. This one I'm going to do a little quicker because we've already done it, and because you should probably learn how to do this as well. First, we can do and the way you can do this simply without going through those whole charts is to first plot the y-intercept, which is negative 6. So 1, 2, 3, 4, 5, 6. Here is the y-intercept. And then we can use the slope, which is always rise over run, to figure out other points. It's 3, so that means up 3 for every 1 over. 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1, and we could really do this as often as we like. And then we go ahead and draw the line, which I'll start over here. And that is our line. Of course, we could put arrows on the ends, write the equation if we like, but this will be the line. Okay, that is number 1. Now let's do numbers 2 and 3. Okay, there we go, blank board. Let's do the next 2 in the same way. Find the equation for the and slope for a line that passes through the points 1, 4, and negative 2, 10. Now over here we don't know the slope, but we can figure out the slope. The slope is the change in y divided by the change in x. Now, change in y means the second y minus the first y, or the first y minus the second y, as long as you're consistent about it. So let's figure that out. Let's take the 2 points. Now, in these points, the change in y is 10 minus 4. What's the difference between 10 and 4? Well, 10 minus 4 is, of course, 6, divided by the change in x, negative 2, 1. That's negative 2 minus 1, which is negative 3. Again, as long as we did it in the same direction, we did 10 minus 4 on top, so on the bottom we'll do negative 2 minus 1. We could have also done 4 minus 10 and 1 minus negative 2. That would have given us the same answer. Either way, 6 divided by negative 3 is negative 2. Now we've got the slope of negative 2, and then we can figure out the b using the same thing as we did in the previous example. Just plug it in. We can use either point, so let's use the first point. It looks a little simpler. Y equals mx plus b. So the y for this would be the 4. Negative 2 is the m. X is the 1 plus b. So that's 4 equals negative 2 plus b. Add 2 in order to isolate the b. Add 2 to each side, and you've got the b equals 6. Which means the equation is y equals mx, and the mx is negative 2. Negative 2x plus 6. That is our equation. Now let's graph it the same way. Plus 6 is the y-intercept, so along the y-axis 1, 2, 3, 4, 5, 6. Let's put this up here. The slope is negative 2, which means 2 down 1 over, 2 down 1 over, 2 down 1 over, and this is going to be our line. Let's draw it using our straight edge. We'll start it from up here, and that is our line. Okay, let's take a look at the next one. And to do that, we'll just put a little fresh graph paper here. Sorry, I cut off a little bit from the previous question, but hopefully you remember that. Okay, and number 3 is really the same idea as number 2. Let's try it in a new color to be a little less confusing. We've got 2 lines, and once again, we have to figure out the m first. We have to figure out the slope first, which is the change in y divided by the change in x. So the slope, again, let's use this first. I'll draw it out this time. 5 minus negative 7 divided by negative 2 minus 0. And that means that 5 minus negative 7 is 5 plus 7, which is 12, divided by negative 2 equals negative 6. So the slope is negative 6. Now let's plug it in. Y equals mx plus b in order to figure out the b. We can use either one. Let's try this one. Y equals, we'll take that as negative 7, equals mx. Our m is negative 6, and our x is 0, plus b, and this is the same thing as saying, well, negative 6 times 0 is 0, which negative 7 is b. Now, of course, we also, and so our y equals mx plus b is y equals negative 6x minus 7. And of course, another thing we could have done is we could have just taken, we knew that the point was 0, negative 7, so we know that inherently that is the y-intercept. So let's plot 0, negative 7. Which is down here. Now I can't, the slope is negative 7, so if we'd have to go down 7, 1 over, or we can just go the other direction. In the left side, we can go up 7. So left 1, up 7. The slope is still going to be in the same way. 2, 3, 4, 5, 6, 7. The slope is still going to go down, but of course we couldn't do it in this direction because we would have run out of room. And let us go ahead and plot it. We'll start from here and go down this way, and that is our line. And now for the last part of homework 10. Number 4 is kind of like the ones that we just looked at. Find the equation for a line with a slope of 1/2 that passes through negative 1 and 3. So we know that the slope is 1/2. I'm going to use 0.5. It's just a little cleaner that way. And we don't know the b, so we'll figure it out. We got y equals mx plus b. We'll use this point that we were given. So the y we'll use as 3 equals the slope, which is 0.5, times x, which is negative 1, plus b, which is 3 equals negative 0.5 plus b. Add 0.5 to each side, and you've got b equals 3.5. Let's graph it. Oh, well, first of all, let's write our equation. Y equals 0.5x plus 3.5, because that's our y-intercept. Let's graph our y-intercept over here, and our slope is 1/2. So that means a half up for every 1 over, which means 1 up, 2 over. Well, we can do the first one. A half up, 1 over. And then we can do, let's say, 1 up, 2 over, 1 up, 2 over, which is the same thing as a half up, 1 over, and then we can just go ahead and draw the line. All right, very good. Number 5, let's quickly go to that one. I'll use a different color here. Find the distance of the line segment that goes from 0,2 to 1,7. So we don't even have to draw this, but I think it's a little easier if we draw it out. So 0,2 is over here, and 1,7 is 1, 2, 3, 4, 5, 6, 7 up here. So we're talking about the distance of the line segment that goes from here to here. Okay. If it were flat, you could just count the number of boxes. Unfortunately, you can't do that, and there are two ways to do it, and they're really the same way. The first way, the one that's most, I guess, algebraic, is applying the distance formula. Distance formula is the square root of the difference in x squared plus the difference in y squared. y2 minus y1 is the same thing as the difference in y. So let's apply that. So let's take our second x is 1 minus 0 squared. And then we've got 7 minus 2 squared, which is the distance equals 1 squared, which is 1, plus 5 squared, which is 25. And so our difference is the square root of 26. Now, how would we figure that out? What's the other possibility? The other possibility is simply imagining this as a right triangle and then using the Pythagorean theorem, which is really the same thing. You know, if you imagine this is a right triangle going from here and then up here, then the red line would be a squared plus b squared equals c squared. And this direction would be 1 squared, plus this direction would be 1, 2, 3, 4, 5 squared equals c squared. 1 squared plus 5 squared is 26 equals c squared. So c would be the square root of 26, which is the same thing we got. Really, these two things are the exact same thing. One is just writing it out, and the other is writing a little bit less of it out. But it's the same idea. All right, third one. Similar problem, except now we are asked to find the perimeter. Four corners, 1, 2, which is here. 7, 2, which is 1, 2, 3, 4, 5, 6, 7. One second. 1, 2, 3, 4, 5, 6. I'm sorry. That's too far. 1, negative 4. 1, 2, 3, 4. And 7, negative 4. Now, this is actually an easy one because all the lines are flat. You don't even have to use the distance formulas. Let's draw the rectangle, it looks like, over here. You don't even really need a graph to do this, but I think it's a little bit easier conceptually if you have it. All right. Now, a perimeter is simply an addition of all the sides. And here again, if you needed to use the distance formula, you could do it for all four sides and then add them all up. Here, you just count the boxes. Well, 1, 2, 3, 4, 5, 6 boxes this way. And then down here, you got 1, 2, 3, 4, 5. Oh, this is also 6, so it's actually not a rectangle. I mean, it is a rectangle, but it's a special type of rectangle called, of course, a square. And a square is, the perimeter of a square is simply 4 times any side. And so, of course, the answer is 24. And that is the, well, it is a rectangle because a square is a type of rectangle, but it's also it's a square. Homework number 11. All right. This is graphing parabolas. Now here, instead of y equals mx plus b form, you want it really ax squared plus bx plus c. In other words, you want an x squared term, you want an x term, and you want just a plain numerical term. Now the first thing you need to do with one of these things is to, when you graph a parabola, is to figure out the turning point. And assuming you have it in this form, you need to get into this form first. The turning point is x equals negative b over 2a, where a is the coefficient of the x squared, b is the coefficient of the x, and c, well, there is no c in this formula, but like in the quadratic formula, it was the constant term. So in this case, our formula is negative b, which is negative 4, which is positive 4, divided by 2 times 2, which is 4. So our turning point is where x is 1. Now, instead of just the 3 points, when I do these sorts of things, I like to make 7 points. You could probably get away with 5, but I like to do 7. It's a little cleaner. So my little charts over here. Unfortunately, you can't just do it the quick way like we did in homework 9. You have to really do it this way unless you have a calculator that does it for you, but I don't want you to use a calculator that does it for you. I want you to do it by yourself, at least the first few times. Let's write in the formula whatever y equals, which in this case is 2x squared minus 4x minus 2. Now, the turning point should be your fourth point. Let's make this a 1, and let's go up and down from 1 in all directions. So in this direction, let's say 0, -1, -2. In this direction, we'll say 2, 3, and 4. And for each one, plug in the x terms for whatever this value is, and then you'll figure out the y. Okay, so let's plug in this, and I'll do this in my head. -2 squared is 4, so that the whole term is 2 times 4, which is 8. 8 minus, well, this is -4 times -2 is positive 8, so that's 8 plus 8, which is 16, minus 2 is 14. Now let's try the -1. 2 times -1 squared minus 4 times -1 minus 2. This becomes positive 1, so this whole term becomes 2. This becomes positive 4, so this becomes 2 plus 4, which is 6, minus 2 is back to 4. Now let's try 0. Of course, this term becomes 0 because anything multiplied by 0 is 0. Everything becomes 0 except for the -2, so that becomes -2. Now let's try the 1. Now we got 2 times 1 minus 4 times 1 minus 2. 2 minus 4 minus 2 is, well, that should be -4. Then we got, let's do it 2 steps at a time. 2 squared is 4, so that's 2 times 4. Minus 4 times 2 minus 2, so we've got 8 minus 8 minus 2, -2. Now we've got 2 times 3 squared, which is 9, minus 4 times 3 minus 2. So we've got 18 minus 12 minus 2 is 4, and then you've got 2 times 4 squared, which is 16, minus 4 times 4, which is also 16. Okay, so we'll make that into 16 minus 2. So 2 times 16 is 32, minus 16 minus 2 is 14. Notice, of course, that if you do this properly, it should go up uniformly. Everything on the opposite sides of the turning points should be equal to each other. And to graph this, just plot the points. You can plot the turning point first. So our turning point is 1, -4. Remember, the turning point was where x was. So x was at 1. Then we've got 0, -2. And then we've also got 2, -2. Notice it's always going to be like a U-shape or an upside-down U-shape, depending on whether this first term is positive or negative. We had -1, +4, that's up here. And we also had 3, +4, which was up here. Then we had 4, 14, which 1, 2, 3, 4. Somewhere up here. I don't know exactly, but somewhere up here, somewhere up here. And then you can draw a nice little U-shape. Okay, not the perfect drawing, but hopefully you get the idea. All right, let us get rid of this and get rid of that little black dot in the interim. Get a new graph paper and go on to question number 2. Let's use green this time. Here, we have to isolate the y first. That's the problem. The problem is in order for this to work, in order for you to easily be able to graph it, you could graph it like this, but it would be much, much harder. So let's isolate the y. And of course, the way we isolate the y first is by adding 4y to each side. So let's put 4y on one side. And then on the other side, we still have our x squared minus 2x plus 9. Now let us divide each side by 4. Divide every term by 4. All right. So we've got y equals 1/4 x, and I'm going to say 0.25x, minus, well, it's -1/2, so I'll say 0.5x plus 9/4, I'll say 2.25. Again, it's just a little easier when you use the decimals. Okay, what is our turning point? Well, let's see. The turning point is x equals negative b over 2a. Negative b is negative 0.5, which is positive 0.5, divided by 2 times 0.25, which is also positive 0.5, and anything over itself is 1. So once again, just like the previous example, we have our turning point as 1. All right. So once we know our turning point is 1, let's make our chart. All right. So what is our chart going to be? We know that it is 0.25x squared. I didn't put that over there, but okay, that shouldn't matter. Minus 0.5x plus 2 1/4. And we have a 1 over here, so let's put, again, 0, -1, -2 up here, and 2, 3, 4 over here. All right, let's try -2 first. -2 squared is positive 4, and 0.25, or 1/4 of 4, is 1. Minus 0.5 minus a half of -2, so that's a minus times a minus, so it's a positive, and 2 times a half is also 1, plus 2.25. So we've got 1 plus 1 plus 2.25 is 4.25. Okay, now let's try the -1. -1 squared is, of course, positive 1. So it's 0.25 times positive 1, which is 0.25. Negative times a negative is a positive again. So negative 0.5 times -1 is positive 0.5 plus 2.25. So now we've got 1/4 plus a half, which is 3/4. 3/4 plus 2 1/4 is 3. Now we go to the 0, so this is easy, 0 and 0, and this becomes 2.25, excuse me. So that's 2.25. All right, now let's try the positives. Let's try the 1. This is going to be our turning point. 1 squared is 1, so that's 0.25 stays by itself, minus 0.5 plus 2.25. Okay. 1/4 minus a half is -1/4. -1/4 plus 2 1/4 is 2. Hopefully you figured out why that is, because again, that's the same thing as 2 1/4 minus 1/4. Now let's try further up. 2 squared is 4. 1/4 of 4 is 1. -0.5 times 2 is 1 also, so that's -1. Plus 2.25. Of course, 1 minus 1 is 0, so this becomes 2.25. And again, notice it's symmetrical. This is the same as the 0. And let's try the 3. 9, x squared is 9. 9 times 1/4 is 9/4, and 9/4 is 2.25. Negative a half, negative 0.5 times 3 is negative 1.5. Plus 2.25. 2 1/4 minus 1 1/2 is 3/4. 3/4 plus 2 1/4 is 3. And then finally 4. 4 squared is 16. 0.25 times 16 is 1/4 of 16, which is 4. Negative a half of 4, which is -2, plus 2.25. So that's 2 plus 2 1/4 is 4.25. And of course, you can see that it does it is the same on either side of the turning point. So our turning point is 1, 2. That's this point. Then we've got 0, 2.25, which is something like this. And we've got 2, 2.25, which is something like this. Then we've got 3, 3, and -1, 3. And then on the edges, we've got -2, 4 1/4, and 4, 4 1/4. So this parabola is going to look a little flatter than our previous one, but it is still going to be U-shaped. And that is what our parabola looks like. And finally, let us look at number 3. I will, let me just try to get rid of this whole thing over here and stick this in back here. And let's look at number 3. Number 3, let's try a third color. Same idea, we have to isolate the y. How do you isolate the y? Well, you get rid of everything else. Get rid of the 3x squared term. Okay, and take the 3x squared to this side. So you've got negative 3y equals negative 3x squared term. We're going to take the x squared term first, and the 12x and the 9 will stay. Now, in order to isolate the y, we have to divide by whatever's next to y, which is negative 3, and we're going to do the same thing to all the rest of them, to this and to this. So this, of course, cancels, and we've got a y. Negative 3 divided by negative 3 cancels also. And you get plain x squared. 12 divided by negative 3 is negative 4x. And 9 divided by negative 3 is negative 3. So this is our equation. And for that, we're going to figure out the turning point. Negative b over 2a. Negative b is negative 4, which is positive 4, divided by 2 times 1. That's the coefficient of the x squared, which is 2. And so our x is 2. So here, when we draw our chart, we're going to do our 2 in the middle. So we'll do a 3, 4, 5, and then we'll do a 1, 0, negative 1. Our equation was x squared minus 4x minus 3. So let's plug it in. X negative 1 squared, positive 1. Negative 4 times negative 1, positive 4. Minus 3. So 1 plus 4 is 5, minus 3 is 2. Okay, that's our first point. 0, of course, that's 0, that's negative 3. Let's take the 1. 1 squared is 1, minus 4 times 1 is negative 4. So we've got 1 minus 4 minus 3, which is negative 6. And then we've got 2 squared, which is 4, minus 8 minus 3. So now we've got 4 minus 8, which is negative 4, minus 3 is negative 7. Now let's try the 3. 3 squared is 9, minus 4 times 3, which is 12, minus 3, which is negative 6, of course, just like the other side. 4 squared is 16, minus 4 times 4, which is also 16, minus 3. 16's cancel, and we got negative 3. And finally, in number 5, we've got 25, minus 4 times 5, which is 20, minus 3, which is 25 minus 20 is 5, minus 3 is 2. So here are our points. Negative 1, 2. Whoops, wrong side. Okay. 0, negative 3. That's our y-intercept. 1, negative 6. That's here. 2, negative 7. That's here. And now we climb back up because we're at the turning point. 3, negative 6. 4, negative 3. And 5, 2. And we draw this. Again, freehand, it's not that easy, especially when you're working on a tablet. But this should be approximately what our parabola, which means our quadratic equation graphed, looks like. Homework number 12 is about conic sections, and we are going to, in the homework, we're going to do one of each type of conic sections that we discussed. We're going to do a circle, we are going to do an ellipse, and then finally we're going to do a hyperbola. Question number 1 is a circle, and the reason why you know it's a circle is because x and y are the same. There's no different denominators. When you have different denominators, that means you know you have either an ellipse or a hyperbola. But when you have an x squared plus y squared equals 16, that means that x and y are equal, which means that the directions, the distances in all directions are going to be equal, which essentially means you have a circle. Now, if you had a different center than the origin, there would be something in parentheses. For example, you might have x minus 1 squared. That means that the center is going to be 1 away from the origin on the x-axis. Now, over here, there is none. Over here, you just have a plane x and a plane y, which means that the center has to, by definition, be the origin, 0, 0, which is the same thing as the origin. So that we don't have to worry about too much. Now, but the other thing that we are asked to do is to graph the circle. Now, graphing it means that you have to first plot the origin, which the center, which we know as being the origin over here. And then we have to figure out what the radius is. And the radius is c squared, whatever this number, the square root of this number. The radius squared is this number, which means it's the square root of whatever this is. And of course, the square root of 16 is 4. It's actually plus or minus 4, but since it's a distance, you drop the negative number. And the radius, that means, is going to be 4, which means the circle is going to have to pass through 4 in this direction, and 4 in all directions, because the circle is completely equidistant in all directions. So we're going to put points over here, points over here, points over here, points over here, and then we're going to have to craft a circle. And again, you're going to have to forgive my penmanship. This doesn't look like a perfect circle, but it's, I guess, close enough. Here's an example of what it should look like. I just used a website to graph it, by computer so that you don't have to worry about my freehand. This is what a classic x squared plus y squared equals 16 would look like. Notice the radius is 4 in each direction, and the rest of it is a perfect circle. Now let's look at the second one. This is not going to be a circle. It is going to be an ellipse, however. Basically, if the two denominators are different, the numerators are always going to be squared. That's how you know it's going to be really a double parabola. If there's only one of them that was squared, it would be a single parabola. It would be either a u or an upside down u. If it were, or if the x is squared. If the y is squared, it would be a sideways a u, either direction, depending on whether y was negative or positive. If they're both squared, it means it's going to be a conic section, which means it's going to be a circle, or a parabola, or a hyperbola. I'm sorry, excuse me, not or an ellipse, or a hyperbola. And whether this is negative or positive depends on whether it's going to be an ellipse or a hyperbola. This is positive, so therefore it is going to be an ellipse, which is kind of like an oval, an egg-shaped drawing. And the way you figure out the center is by figuring out the negative of whatever's over here. So up here, let's say, for example, you have x minus 2, which means the x value of the center is going to be positive 2. This is negative 2, so you just kind of take the negative value of this and make that into the center. And then on the right side, you've got the y value, which means the negative of negative 1, which is positive 1. So this is going to be the midpoint. I don't want to call it the center. Center is something that's usually referred to when you're talking about a circle, but this is the midpoint of the ellipse. Then you have to figure out what is called the axes. In other words, how far is each point away from the center? First of all, let's plot the center here. Excuse me, our midpoint is going to be at 2, 1, which is over here. Now, how far away are the edges of the ellipse going to be from the midpoint? And the answer is, you look on the x-axis, it is going to be the square root of whatever this number is. And on the y-axis, it's going to be the square root of whatever that number is. So the distance from the center, or the axes along the x-axis, is going to be the square root of 9, which of course is 3. And then the axis, the minor axis, the smaller axis, the one along the y-axis, in this case it's smaller because the denominator is smaller, it could be larger, is the square root of 4, which of course is 2. which means along the x-axis it's going to be 3 away in each direction. One over here, and then one over here. And on the y-axis, in other words on the vertical axis, it's going to be 2 away, which means one over here and one over here. And again, drawing it freehand, it's going to look something like this. And again, I just put it computer done just to show you what it looks like, and it looks, fairly similar to the one that I did. The center being 2, 1, which is right over here, the midpoint. The longer axis being 3, 1, 2, 3, and the shorter axis being 2, 1, 2, and the edges being kind of roundish or oval. The question also asks us for the foci, or the foci. And the way to figure that out is to apply the focus formula. And the focused formula is the square root of the bigger one minus the smaller one, the bigger denominator minus the smaller denominator. So in this case, the focus is the square root of 9 minus 4 equals the square root of 5. Now the square root of 5 is a little bit more than 2. Actually about 2.24, so a little bit less than 2 1/4. So that's away from the center, away from the midpoint. So 1, 2, so this is going to be one focus. Let's make it a different color just to indicate that it's something a little different. So one focus is going to be right around here, and the other focus is going to be right around there. And you can see the underlying lessons for an explanation of what foci are and what their role is. Number 3 is a hyperbola, and the way you know it's a hyperbola is because it has a minus sign in the middle over here. And by the way, it would be a hyperbola even if x and y had no denominators. As long as there's a minus sign over here, it means they're going in opposite directions. You're going to have one thing in one direction and the other part in the other direction. And so the first thing we're going to do is we're going to define all the things just because it's a little more complicated. What is the a? Now the a in this case is the denominator, always is the denominator of the x term, so the square root of the denominator of the x term. So our a is 3. Our b is the square root of the denominator of the y term, so that's 4. And we can also define h and k. H being the negative value of whatever is next to the x, and k being the negative value of whatever is next to the y. So in this case, h would be negative 4, because this is the opposite of positive 4, and the k would be negative 3. So what are we asked for? We're asked for the center. And now the center is, of course, going to be hk. So our center is easy. Center is whatever the negative value of this and the negative value of that, so it would be negative 4, negative 3. Okay, that's the first part. The vertices, just like we saw last time, the axes, before I called them axes, now they're vertices. Either way, it's the same idea. The vertices are the distance from the center that each line is going to touch. And in an ellipse, it means the furthest distance. In a hyperbola, it's actually the closest distance that it is actually going to apply to. And the distance, well, from the x-axis, the vertices along the x-axis is going to be the square root of 9, which is 3 away from the center. And the vertices on the y-axis is going to be the square root of 16, which is 4 on the y-axis. So if we, well, actually, that would be in an ellipse. In hyperbola, you're only going to have one set of vertices, because it's going to, the ultimate hyperbola is either going to be something like this or something like this, where the 2 points are never going to touch each other. So let's graph the center. The center was negative 4, negative 3, 1, 2, 3, 4, 1, 2, 3. And, as we discussed when doing the material, because of the fact that the x value is first, the centers, or the lines themselves, the vertices, are going to be along the x-axis. And so therefore, if you count the x-axis, it would be 3 away. So the red is the center. I'm going to use the orange for the vertices. And that would be 3 over in this direction. 1, 2, 3. and 3 over in the other direction. So it looks like this one is negative 7, negative 3. And this one over here is negative 1, negative 3. Notice because the x value is first, x can never actually be 0. Because if x were 0, then you cannot subtract something from it and still get 1. This has to be a positive number. Because this has to be a positive number, the x-axis never gets crossed. And again, because it's shifted a little down because the center is different, it means that this can never be crossed. So this hyperbola is going to look something like this and this, two outer facing half circles in opposite directions. It's going to look something like this. And of course, I'm going to graph it a little bit later on and show you what it looks like on the computer. So now we've got the vertices. The equations of the asymptotes, or the asymptotes, would normally be, let me get a different color over here, would normally be y equals b over ax. Now, of course, over here, because of the fact that the center is different, you have to adjust for the fact that the center is different. So instead of just being y, it would be, I guess, y minus k equals plus or minus, I forgot the plus or minus before, plus or minus b over a times x, but instead of x, you'd have to do x minus h. In other words, you would have to simply adjust for wherever the center is. So if you plug these in, you're always going to get two different asymptotes. So let's plug all these in. So we've got y minus, well, minus k would be plus 3 equals plus or minus b over a, which is 4 over 3, times x plus 4, minus negative 4. And then you could simply make each one y equals mx plus b. Let's do a positive and a negative, so let's split them up over here. Let's do the positive on this side. On this side, we'll do y plus 3 equals 4 times x plus 4. And that becomes 4x plus 16. So we'll do y plus 3 equals 4x plus 16, and then subtract 3 from each side. Sorry, I forgot to put this denominator there, so it's actually 4/3 x. So it's actually 16/3. 16/3, subtract 3 from each side, and you get y equals 4/3 x. And then 16/3 minus 9/3 is 7/3. So that would be one equation. And the other one would be the negative value. The other one would be y plus 3 equals negative 4/3 times x plus 4. So you've got y plus 3 equals negative 4/3 x minus 16/3, and again you'd have to subtract 3 from each side, so you've got y equals negative 4/3 x, and then negative 16/3 minus 9/3 is minus 25/3, which is 8 1/3. So these would be the two asymptotes. So basically, I'm going to draw this with a computer. It'll just be, oh, I'm sorry, but it's going to look something like this, whatever. And the asymptotes are going to look something like this. They're all going to cross through here, and they're going to look like this. So what I'm going to do is, rather than use my free hand, I'll graph it, and I'll show you what it looks like on the computer. Okay, so this is what the hyperbola would look like. Notice our center was negative 4, negative 3. The vertices were 3 away in each direction, 1, 2, 3, and 1, 2, 3. And the asymptotes would go something like this. One would go from here all the way down here, just never actually hitting the line, and the other would go down in the other direction. Homework number 13 is about systems of equations. You have two different equations, each with two variables. Normally you cannot solve an equation that has two variables, but if you have systems of equations, you have two equations you can. And the way you can do that is by substituting, addition, or graphing. And we're going to do each of these at least once on the homework. Okay, so For number 1, we asked you to do it via the substitution method. Now you can take either equation and isolate x or isolate y and then apply it in the other. Now just by looking at this, I can see there's 4y on this side and 3y on that side, so I can see right away in the bottom equation is going to be fairly easy to isolate y by itself, because if I take away 3y from this side and 3y from this side, I've just got one single solitary y left. So just by looking at it, it seems like isolating the y in the bottom equation is going to be much easier. It'll work the other ways. It'll just be much harder. Okay, so the way we're going to do this, subtract 3y from each side. Once you do that, now you've got 1y left. You've got 3x plus 1y equals x minus 14. And now, to isolate y, we can subtract 3x from each side. And we've got 1y left equals x minus 3x, which is negative 2x, plus 14. So we know that y is negative 2x plus 14. So now we can take, let's say, this equation, and instead of y, we can use negative 2x plus 14. So let us write the equation. 2x minus 3y equals 8 minus 2x. So 2x minus 3, and instead of y, we're going to say negative 2x plus 14 equals 8 minus 2x. So let's distribute the negative 3 to open up the parentheses. At this point, it's just a regular equation. Keep the 2x. Negative 3 times negative 2x is positive 6x. Negative 3 times positive 14 is negative 42 equals 8 minus 2x. Let's continue to isolate the x by combining. 2x plus 6x is 8x minus 42 equals 8 minus 2x. Let's put the x's on one side, numbers on the other. This is a negative, might as well do it this way. You can do it the other way too. Add 2x to this side, add 2x to that side. Then to get rid of the 42 from this side, add 42 to this side and add 42 to that side. 8 plus 2x is 10x equals 8 plus 42, which is 50. Divide each side by 10, and x equals 5. Once you have the x, now you can simply plug it into either equation to figure out the y. All right, let's try the top equation. Looks a little simpler. 2x plus minus 3y equals 8 minus 2x. We're just substitute substitute 5 for the x's. Minus 3y equals 8 minus 2 times 5. 2 times 5 is 10. Minus 3y equals 8 minus 10. 2 times 5. Okay, now we can just say 10 minus 3y equals negative 2. So 8 minus 10 is negative 2. Isolate the 3y by subtracting 10 from each side, and we've got negative 3y equals negative 12. Divide each side by negative 3 to isolate the y, and we've got y equals 4. Okay, that was simple enough. Now if we want to check it, just to make sure we're right, let's take each equation and see if they work. The top equation is 2x minus 3y equals 8 minus 2x. So 2 times 5 minus 3 times 4, again this was 3 times y, equals 8 minus 2 times 5. Okay, 10 minus 12 equals 8 minus 10. And of course 10 minus 12 is negative 2. 8 minus 10 is negative 2. It works. Let's take the bottom one. 3 times x, no problem, 3 times 5, plus 4y, 4 times 4, equals x, which was 5, plus 3y, 3 times 4, plus 14. Let's see if it works. 3 times 5 is 15, plus 4 times 4 is 16, equals 5, plus 12, plus 14. On the left side, we've got 31, and on the right side, we've got 31. Very good. All right, let's try number 2 now. Now, number 2, I think it's actually a little simpler. Let's try the substitution method. I'm sorry, the addition method. And the addition method is going to work by trying to get both equations to have the same term, one positive and one negative, so that you can simply add the entire thing together and wipe out one of the variables. Right now, if you added these equations together, which you can do, you'd get 6x, minus 2y. That wouldn't help you. But if we could get, for example, this to be 4x and this to be negative 4x, then we could add the equations together and wipe out the x. How do you do that? Well, it's simple enough. Subtract and multiply this by negative 2. You can multiply this by negative 2 as long as you do it to everything else in its equation. Remember, that's the beauty about algebra. So what if we multiply this entire equation by negative 2? So the x term becomes negative 4x. The y term becomes positive 10y. Negative 5 times negative 2 equals 1 times negative 2, which is negative 2. Now we could add the equations together, and that would wipe out the x term. 4x minus 4x wipes out. 3y plus 10y is 13y equals 15 plus negative 2, which is 13. And of course, divide each side by 13, and that gets you y equals 1. Simple enough. Now let's figure out the x, and we can use either equation to figure out the x. Let's use the top one, I guess. Makes no difference. What do we got? 4x plus 3y equals 15. That's 4x plus 3 times 1, because that's what y is, equals 15. 4x plus 3 equals 15. Subtract 3 from each side, and we've got 4x equals 12. Divide each side by 4, and we've got x equals 3. Let's check it. With the first equation, what did we have? We had 4x plus 3y equals 15. 4 times 3 plus 3 times 1 equals 15. Let's see if this works. 12 plus 3 equals 15, which of course works. Now let's try the bottom equation, which was 2x minus 5y equals 1. 2 times 3 minus 5 times 1, which is 1. 6 minus 5 equals 1, which of course it does. Here we're asked to solve this system of equations graphically and algebraically. So I've got a piece of graph paper over here, and I would like to do it algebraically as well. And let's do it algebraically first. We can use substitution or addition. I think addition is probably slightly easier over here, because we've got x plus 3y equals 11. X minus 5y equals negative 13. Well, remember, if we do addition, we could substitute by, let's say, subtracting 3y, and you get x equals negative 3y plus 11, or 11 minus 3y. You could do that, but I think if you just subtracted, let's say, by making everything negative, multiply everything by negative 1. Well, now you're going to get the opposite of the x. You're going to get negative x, and then this is going to turn into positive 5y, and this is going to turn into positive 13. Now, if you add the equations together, you're wiping out the x term. X minus x is nothing. 3y plus 5y is 8y. 11 plus 13 is 24. And then divide each side by 8, and you've got y equals 3. And x, on the other hand, well, x plus 3y equals 11. So that means x plus 3 times 3, which is 9, equals 11. And you can see right away that x is going to equal 2. So we could check, or we could do the equation graphically. If we do the equation graphically and we get the same answer, I think that's just as good as a check. And let's check orally, just for kicks. X is 2, plus 3 times 3 is 9. That's easy. 11, that works. X is 2. 2 minus 15 is negative 13. So they both work right away. But let's graph them both, because that's what the question asked. Okay, first question. X plus 3y equals 11. Now, really, you should get it into y equals mx plus b form. You know what? Don't tell anybody, but I'm not even going to do y equals mx plus b form. We could, you know what? Let's do it. That's the proper way to do it. You don't typically have to. It'll be a little harder, but we can figure it out. Okay, subtract x from each side to get the y all by itself. So you've got 3y equals negative x plus 11. Divide everything by 3. So you've got y equals negative x over 3, or negative 1/3 x, plus 11/3. All right, let's graph it. We got the x and the y. We'll do it up here. Okay, and y was negative 1/3 x plus 11/3. Let's do 0, 1, 2. Okay. X is 0, so obviously this term is 0, and y becomes 11/3. Okay. Let's see. This is negative 1/3 times 1, so that's negative 1/3 plus 11/3. Well, negative 1 plus 11 is 10, so that's 10/3. Well, but let's write it out. This is really 2 2/3. This is really 2 1/3. Sorry, 3 2/3, and this is really 3 1/3. And the last one is negative 1/3 times 2, which is negative 2/3 plus 11/3. And this is going to be 9/3, which is 3. So let's graph it. We've got 0, 2 2/3. That's, excuse me, 0, 3 2/3, which is here. 1, 3 1/3, which is here. And then 2, 3, which is here. So let us draw our line. I can see the slope is negative 1/3, which means I'm going to make sure it's on the thirds on each third. Okay, that looks about right. Let's do it the other way as well. Okay, that looks good for the first equation. Now for the bottom equation, let's do what did we have? We had x minus 5y equals negative 13. So subtract x from each side, just like we did before. We got negative 5y equals, let's see, negative x minus 13. Divide everything by negative 5 to isolate it. Negative 5, negative 5. So we've got y equals positive 1/5 x, because negative divided by a negative is a positive. And this is negative 13 divided by negative 5, which is positive 13/5, which we'll call 2.6. So let us make our chart. And what do we have? We have y is 1/5 x plus 13/5, or 2.6. Let's again do 0, 1, 2. So that's 0 plus 2.6 is 2.6. 1/5, which is really the same thing as 0.2 plus 2.6 is 2.8. And the third thing is 1/5 of 2, which is 2/5, which is 0.4, plus 2.6 is 3. So let's make our 3 points. 0, 2.6. Which is, I just realized that I put this on the wrong line, so I'm going to re-graph this. Sorry. Try to pretend this doesn't here. I apologize, but I don't want to do the whole video over. Hope you don't mind. I realized when it was 0, 3 2/3 was actually over here, not there. I did the wrong line. This should have been 1, 1, and it should have been like this, was the actual 3 lines. So let me graph that line again, starting from the correct place. I hope you didn't see it wrong and then were panicking. But yeah, that is a mistake on my part. I do apologize, but I'm going to re-graph it. Okay, that should definitely work. So that second maroon line is correct. So now let's go ahead and graph the bottom equation over here. 0, 2.6, which is here. 1, 2.8, which is here. And 3, 2, which is here. And I'm going to now graph the blue line. Which is going to look something like this. And we can see where they crisscross. Well, we can see just from over here, 2, 3, and 2, 3, both points are on both lines. So those are our answers. Our answer is 2, 3, which is where they crisscross on the graph, and we can see it plain here. It also confirms what we looked at before, that y was 3 and x is 2. They cross at x2 and y3. And finally, question number 4. The thing that makes this a little bit harder is the fact that this is actually a quadratic equation. But that's okay. We can use the exact same method that we did before. I'm going to recommend using the substitution method. It just makes things a lot easier. You could use the addition method as well by getting them to line up and making. You're not going to get an x squared and you're not going to get an x and a negative x because you've got an x squared over here. You could do it with the y, so you could do it either way. But I think substitution is going to be a little bit easier. In order to do that, we are going to want to use the y. We already have what y equals. So we could just simply apply the x squared minus 4 to the top equation. So x plus y, and y is x squared minus 4. I'd usually put it in parentheses, but since it's adding, it's the same exact thing, equals 2. Now once you have this, you have a quadratic equation. Now a quadratic equation should be put in ax squared plus bx plus c equals 0 form. So first of all, let's switch the order. Instead of x being first, let's do the x squared first. And I'm sorry, this shouldn't be squared, of course. I just flipped the order just because that's going to be the easier way to factor it. Now we can set the whole thing equal to 0, which is always the point of a quadratic equation. And the way to do that is, of course, to subtract 2 from each side. So you've got x squared plus x minus 6 equals 0. And now we can use the quadratic formula. We can use whatever we like, but the easiest way to do it is simply going to be to factor, which this works. I tried it before I turned on the video. We've got x and x. This is a negative, so we're going to have a positive and a negative. We need two numbers that multiply up to 6 and add up to positive 1. And of course, there's 6 and 1. That's not going to work, but there's 3 and 2, and 3 and 2 will work. It'll work if we make the positive the 3 and the negative the 2, because that will add up to positive 1, which is the coefficient of x, and it'll multiply up to negative 6. Then we set each side equal to 0. Subtract 3 from each side, and you've got x equals negative 3. Add 2 to each side, and you've got x equals 2. So you've got two different possibilities, and for each one, you can figure out a different y. As we'll see, you actually have two, just like with most quadratic equations, you've got two different solutions. The top one is by far the easier one, so x plus y equals 2. Let's substitute negative 3 for x. Negative 3 plus y equals 2. Add 3 to each side to isolate y, and you've got y equals 5. Easy enough. And on the other side, you've got x is 2. So x plus y equals 2. X is 2 plus y equals 2. Subtract 2 from each side. And y is 0. So we've got two solution sets over here. We've got negative 3 and 5, and we've got 2 and 0. Let's do it on the graph and see if that works. Let's graph both equations. Let's first graph the easy one, the x plus y equals 2. Let's get it into y equals mx plus b form by subtracting x from each side. So we've got y equals negative x plus 2. Very easy. Negative x plus 2, and let's again use 0, 1, 2. Negative 0 is 0. Plus 2 is 2. Negative 1 plus 2 is 1. Negative 2 plus 2 is, of course, 0. So let's graph that. That's easy enough. 0, 2, which is here. 1, 1, which is here. 2, 0, which is here. So let's go ahead and graph the line. You can see the slope is obviously negative 1, y equals mx plus b form. And it's negative x, which means negative 1. And let us graph the line. I'll do it in both directions, again, just to make it nice and long. And that is our line. Okay, now let's graph the harder one. Let's graph the quadratic one. Well, the quadratic one this time is not very difficult. We're going to first find our turning point, like we always do. Now our turning point is x equals negative b over 2a. In this case, there is no b. See, the middle term is missing. So it's negative 0 over 2a, so the x is 0. So by definition, our turning point is going to be 0. Again, the middle term is missing. There's no coefficient of the x, so it's 0. So our turning point is 0, which means when we do our 7 lines, which we like to do when it comes to a quadratic equation, our 7 different points. Okay, our y is x squared minus 4. And we're going to put 0 in the middle this time. So we'll put negative 1, negative 2, negative 3, 1, 2, 3. Okay, let's say negative 3 squared is positive 9 minus 4, 5. Negative 2 squared is positive 4 minus 4, 0. Negative 1 squared is 2 minus 4, negative 2. 0 minus 4, negative 4. And with the ones, you see, negative something squared and positive something squared is the same. So this is going to be 1 squared. Sorry, what am I talking about? This wasn't. Negative 1 squared was positive 1, so that's negative 1 either way. Fine. It's going to be the same thing. 1 squared is 1 minus 4. What am I doing? Sorry about that. This was, of course, 1 minus 4, which was negative 3. Apologize for that. Here, 1 minus 4 is also negative 3. 2 squared minus 4 is 0. And 3 squared minus 4 is also 5. So let's graph it. Negative 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. Notice this is one of our solution sets. Negative 2, 0, which is here. Negative 1, negative 3, which is here. 0, negative 4, which is here. 1, negative 3, which is here. 2, 0, which is here. And 3, 5, which is here. Meaning our parabola looks something like this. All right. Now, where do they meet? Well, they meet right over here, which is negative 3, 5. And they meet right over here, which is at 2, 0. Those are our two solution sets. And of course, those match what we got when we did substitution, negative 3, 5, and 2, 0. So both methods confirmed the solution sets. Homework 14 is logarithms. Logarithms are really just another way of writing exponents. Relatively easy stuff over here. And so we are going to do this fairly quickly because it's fairly easy stuff. All right, so this is one form of logarithm. Logarithm of base 2, 16 to the 4, which this essentially is the same thing as saying the base to what power gets you 16. And in this case, of course, it's 2 to the 4th power gets you 16, which of course is true. So if we write it in exponential form, it's really not any more complicated than writing 2 to the 4th equals 16. In these homeworks, you can see whether it's true, and if it's not true, you can bet you probably messed up somewhere. But anyway, that is of course true, because 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. Okay, so this is the same thing. This to this power is this. 3 to the 2 is x. Now it doesn't ask you what x is, but of course x is 9, easy enough. Number 3, this time the power is what's on this side. So it's the base to the y power equals 216. And of course we don't ask you what y is, but y happens to be 3, because 6 to the 3rd power is 216. 6 times 6 is 36. 36 times 16 times 3, it's 36 times 6 is 216. Here, we're just doing the reverse. We're taking things that are in exponential form and putting into logarithmic form, which is the same way. This is what is getting raised, which is the 2. This is the equal on the other side. And on the other side over here is the exponent, which is 3. That's easy enough. And for number 5, the base is, of course, b. The number over here is 1,000, and the logarithm is the power, which in this case is also 3. If you want to know what b is, well, b, of course, has to be 10, because it's 10 to the third power. That equals 1,000. Okay, number 6. Well, this was continued from the previous question, from the previous page, where we asked you to figure out put it into logarithmic form. And just like we did before, you put the log with the base over here, which is 15. The x is over here, and the exponent will be on the other side. If you want to know what x is, well, you can just go back here. What's 15 squared? And 15 squared is, of course, 225. So even though it wasn't asked, it's nice to know that x is 225. Here we are asking you to figure this out and to evaluate each expression. The easiest way to do this is to simply set it equal to some variable. Set each one equal to x, and then you'll figure it out. If you put this equals x and that equals x, then when you look at it in exponents form, it'll be a lot easier to figure out. So 4 to something equals 16, which means 4 to x equals 16. 4 to the what is 16? Well, I think it's pretty obvious that 4 is 2, because 4 squared is 16. Let's take this one. This is 5 to the x equals 1/5. Well, remember we discussed way back, I think it was maybe even in class 1, that a negative exponent puts a number on the denominator from the numerator. So to get 5 into 1/5, all you really need to do is raise it to the negative 1 power. If it was the negative 2 power, it would be 1 over 25. If it was negative 3 power, it would be 1 over 125. If it was negative 4 power, it would be 1 over 625. But for this, all you need is x equals negative 1, because if you raise 5 to the negative 1, that becomes 1/5. You're just taking the numerator and putting it into the denominator. What about number 9? Number 9, you've got 64 to the x equals 8. Well, what do you got to raise 64 to get 8? 8 is the square root of 64. So we'd like to make the 64 square roots, and a root is a fractional exponent. So a square root is the same thing as the 1/2 power. So x is actually equal to 1/2, because 64 to the 1/2 power is the square root of 64, and the square root of 64 is 8. And finally, we've got base 4, and we've got 1 as the answer. So we've got 4 to the x power equals 1. Now, this may be a little tricky. You just have to remember that anything gets you 1 if it's raised to the 0 power. 1,000,000 to the 0th power is 1. Everything to the 0th power is 1. So the answer is x equals 0, because 4 to the 0 power, just like everything else to the 0 power, is 1. And that's the only way to get that in this case. Homework 15 is about condensing logarithms, making them simplifying them, which is something that we learned about, obviously, in the original videos, in the original practice materials. There are a series of rules by which you can condense logarithms, so if you haven't already done so, obviously, you should go over those. But in this case, we could make things a lot simpler, and for number 1, remember that subtracting a logarithm is the same thing as putting the two terms over here on dividing. Subtracting an entire logarithm is the same thing as dividing the expressions that are subject to the logarithm. So log base 2 96 minus log base 2 3 is the same thing as log base 2 of 96 over 3. Now here, of course, you can simplify it a little bit, because we know 96 divided by 3, and 96 divided by 3 is 32. So really, this is the same thing as saying log base 2 of 32. Now here we can actually figure out what that is, because this means 2 to a certain power, whatever that power is, equals 32. 2 to the x equals 32, and x actually is 5, because 2 to the 5th power happens to be 32. Not always going to be able to simplify it. In fact, on this page, I think it's the only one that you can actually simplify like that, but you can do it in this case. Number 2 is we've got a log, and again, if there's no base, the presumption is that it's a base 10. So same rule. Subtracting is the same thing as dividing what is being subject to a log. So this is the same thing as log with no base, which means base 10, of 2x plus 5 divided by x. Now, I don't see that there is any real way to simplify this anymore, so we can just leave it like that. Sometimes you're going to have problems where you can simplify it in multiple steps. Here, I don't really see that as being applicable. Okay, now this one, number 3, is something that we can do in terms of both steps. And that is, we've got a multiply of a logarithmic term is the same thing as putting whatever the coefficient is as the exponent of the term inside. So this is really the same thing. If we leave log x for a second, this is really the same thing as log y to the 3rd power. Now we can combine them, because 2 expressions of logarithms being added to each other is the same thing as the expressions multiplying. So this is the same thing as log of x times y to the 3rd. Again, you can see it's definitely a slightly more simplified expression than the original one. Number 4 is actually very similar. Here we have a 1/2, and we could make this x to the 1/2, and of course x to the 1/2 is the same thing as a square root, as we discussed a little while ago in the previous homework. So this is really the same thing as ln. ln, of course, means natural log, which is a log with a base of e. So natural log x to the 1/2 power, which is the same thing as the square root of x, plus ln of y, is the same thing as ln square root of x times y. Remember, the y is not inside the square root, because the term is being multiplied by y, but this is the simplest that you can apply it to. And the next one is really the same idea. Again, we can multiply. This time we actually have 2 times the loggers being multiplied, so we can put the 2 over here, and we could put the 3 over here, which means log base b. Again, they're both base b in this case. If they're different bases, you can't combine them at all. But we've got an x squared plus 3, or we can make this log base b, and we moved the 3 to the exponent of y, and then we could simplify it one more time by saying log base b x to the 2nd times y to the 3rd. Again, really the same idea that we did before, except we had 2 exponents here that we were able to simplify. Numbers 6 and 7 are virtually identical to the ones that we've looked at so far, so let's do them relatively quickly. We've got a 4, which we can make as the power to the x plus 6, and a 3 that we can make as the power to the x. Again, we're talking about natural logs, so we can combine them. So we've got ln of x plus 6 to the 4th power minus 3, or minus ln of x to the 3rd power. And then to combine them, since it's subtracting, we can divide them. ln of x plus 6 to the 4th power divided by x to the 3rd power. And I don't see any way to really combine it. Maybe you could multiply this out, and probably not. You'd have to do x squared plus 12x plus, well, you'd have to, it would be, I think you can just leave it like this. It's fine. All right, so number 7 is the same thing. We've got 3 terms, but the principles are the exact same. They're all natural logs. 3 ln x is the same thing as ln x to the 3rd, plus 5 ln y is the same thing as ln y to the 5th, minus 6 ln z to the 6th. And then you can multiply the top 2 and then divide it by the bottom. So we could make this into one big natural log with x to the 3rd times y to the 5th on top, and then divide by z to the 6th. See, because this was an addition, so we multiplied, and then we subtracted, so therefore you can divide that. And they're all under one big natural logarithm. Okay, the last part is solving equations by getting the same base. So let's just say, without even looking at this, let's say I said, for example, I told you that x to the second equals x to the y minus 1, something to that effect. And I asked you, what's y? Well, since the bases are the same, the exponents must be the same as well, because the whole expression is equal. So then that would mean that 2 equals y minus 1. And then you add 1 to each side, and you get y equals 3. So y has to be 3. I mean, it's common sense that y has to be 3. Same thing is true, for example, if I say 7 to the x plus 2 equals 7 to the 10th, well, then they have the same base, so x plus 2 has to equal 10. So x is 8. Problem is, first you have to get it to the same base, otherwise you can't do this. Well, let's see by number 8. Number 8, neither of these are in and of themselves the same. Obviously, they're not the same base, and it's not that easy to get the 625 into the 125 base, but you can reduce them both if you recognize them. You can reduce them both to a 5 base, because 125 is 5 to the 3rd power, and 625 is 5 to the 4th power. So this is the same thing as 5 to the 3rd power times x, because the x is still there. So you see why it's the same thing? 5 to the 3rd is 125. So 5 to the 3x is the same thing as 125 to the x, equals 5 to the 4th power, because that's 625. Now that they've got the same base, you can set them equal to each other, which means 3x equals 4, divide each side by 3, and you've got x equals 4/3. Second one, again, you have to set them equal to the same base. E is the base on the left side, that's fine. On the right side, can you make e the base as well? Sure. Remember what you do to get something to the denominator, like we did on the previous homework as well? You raise it to the negative 1. Just like, for example, 3 to the negative 1 was 1 over 3. So e to the negative 1 is 1 over e. So 1 over e is the same thing as e to the negative 1. Now we've got the same base. So we can drop the e's and say x plus 1 equals negative 1. Now we can subtract 1 from each side, and x equals negative 2. And finally, here, again, it's not going to be quite as easy, because 16 doesn't, you can't just put 8 to some power. 8 to the 2nd power is going to be 64. But you can drop them both. And if you recognize them, you can realize that both are powers of 2. 8 is 2 to the 3rd power, and 16 is 2 to the 4th power. So if we drop them both to base 2, so we have to raise this expression to the 3rd power just to get 8. And of course, the x plus 3 doesn't go anywhere. So we're going to do 3 times x plus 3. See why that is? 2 to the 3rd power is 8, but it was already being raised to the x plus 3. So you can say this expression is the same thing as 2 to the 3rd times x plus 3 equals 16. We're going to drop to 2 also. Instead of putting a 3 over here, we're going to need to put a 4 over here, because 2 to the 4th power is 16. And of course, the x minus 1 stays as well. Now that we've got the same base, we can drop the 2's and set the exponents equal to each other. 3 times x plus 3 equals 4 times x minus 1. Open up the parentheses and solve like you would a very simple equation. 3x plus 9 equals 4x minus 4. Let's say subtract 4x from each side, and then subtract 9 from each side, and you've got negative x equals negative 13. Divide or multiply each side by negative 1, just make everything positive, and you've got x equals positive 13. And if you want to check it, you can check it based on this equation over here. Let's check 3 times 13 plus 3 equals 4 times 13 minus 1. Well, 13 plus 3 is 16. 13 minus 1 is 12. 3 times 16 is 48. 4 times 12 is 48. So it checks.